All right. Good morning, everyone. How's everyone feeling today morning? Good? Okay? Nah? I see some smiles. Okay, I see a lot of them saying good. Please keep the energy up high. By way of introduction, my name is Prithvika, and I'm part of the cloud marketing team here, and I'll be your host for today. I'm super, super thrilled and excited to be here with all of you all. Today, we want to dedicate Developer Day event to all of you all because all of you have been creating such amazing, elegant code, starting from there to groundbreaking applications. And that is the future of technological advancement that we want to be a part of at Google Cloud. We want to be a part of every step through that journey. Now, without waiting any further, it's indeed my honor to invite upon Gabe Monroy, VP and GM, Developer Experience, to provide the keynote talk. Let's give him a warm welcome, please.
Good morning, everyone. Welcome to the Developer Day event. I'm so excited to be here. I've actually been spending the week here in India and meeting with customers and partners. I've been so impressed with the amount of energy and just a skill and vision for the future that I've found in this country. It's been very inspiring. But today, we're going to be here to share a bit about what's going on inside of Google from a GenAI perspective, but really viewed through the lens of a developer. So really excited to dig into this. And this day is really dedicated to all of you who are building the future in application development. We're really excited to share some of the newest of what's going on inside of Google Cloud. So we've got some demos. We've obviously got some content that I'm going to run through here. I got some partners who are going to be joining us on stage, sharing what they've been building as a partner of Google. Really, really excited about this. Okay, so today we're going to start with talking about supercharging app development and productivity with generative AI. So that's going to be the focus. As was mentioned, my name's Gabe Monroy. I'm the Vice President and General Manager for Developer Experience. So I look after developer things across Google Cloud. Look after lots of different services. I'm not going to bore you with them today. But the reason I'm here in India and the big focus is around coding assistance to use AI assistance to help you build applications. And then also how you build apps that use generative AI. So we'll be covering both of those things today. But first, let's start at the high level, right? Let's talk about generative AI overall. GenAI is, we hear it's evolved very quickly from being just a buzzword to being something that's actually delivering meaningful business impact and impacting the lives of humans every day. How many people in the audience are using chatbots today as part of their GenAI chatbots? That's basically every hand in the room, right? So this is no longer just a technology fad. This is becoming something very real. Now, at Google Cloud, our mission is pretty simple. We want to make AI helpful for everyone. So we're committed to democratizing AI, making it accessible to everyone, no matter where you are in the world. And we're going to talk through some examples of how we're doing that. Now, we think about AI in three broad spectrums, right? The first one is personal, societal, and with business. Now, I'm sure folks are familiar with the Magic Eraser, which is a pixel feature. It uses generative AI to remove unwanted objects in images. It's responding to 8 billion queries a month, right? And this is something that Google has a lot of expertise with. YouTube automatically generates captions for videos and does that at a huge, huge scale, helping those who are maybe deaf or hard of hearing to participate in the video content. Smart Compose in Gmail, help me write something inside of Gmail. That also uses generative AI. AI is all around us already today, and Google has been at the forefront of that. So we're very, very proud of our accomplishments there. Now, similarly, in the enterprise side of the world, generative AI is helping businesses transform themselves like never before. Financial services businesses are delivering better experiences for customers. Media and entertainment are able to get more creative with GenAI tools, image and video editing and the like. And of course, customers in technology and IT are also using GenAI to radically transform developer productivity. And so that's really what we're going to talk about today is the developer productivity piece and how we're revolutionizing software engineering. Gemini Code Assist is the flagship product that we have at Google that is helping developers in how they write code, how they test code, how they do code reviews, and even help developers in their least favorite task, in my experience, which is how they write documentation. Something that Gemini turns out to be pretty good at. Now, since all you in this audience are developers or certainly technical, at least that's been my understanding, today I'm going to focus on two things. The first is how we're boosting developer productivity using generative AI, right? And that's as a productivity boost in writing code, et cetera. And then the second is how we're going to help our customers create their own GenAI applications. I'm sure many of you in the audience are looking to build new things using LLMs, using multimodal models, and we're going to show you how we can make that even easier than ever using Google Cloud. Okay, so first, let's talk about developer productivity. Now, as I mentioned, Gemini Code Assist is your trusted AI coding assistant. It brings the power of Gemini into the most popular code editors that you all are probably using day in, day out. And it's now available with Gemini Pro to all users. Now, when thinking about coding assistants, I think it's important to recognize that many of these solutions have a lot of table stakes, kind of basic features. They're very important though, so I want to kind of run through what some of these are. The first is code completion. So this is the idea that as you're typing inside of your editor, you're writing a method or a line of code, you're getting predictive, completion in terms of what you write. And that predictive completion is powered by AI, right? It's not just a very simple prediction. It's actually sending the content to an LLM, processing that, and giving you a predictive type ahead. And this is something that you'll see as kind of like text showing up in gray in front of your cursor, typically in IDE. Code completion. Second is code generation. Now, this is one of the more powerful features in AI coding assistants. This is where you can use natural language prompts inside of your IDE. You say, hey, write me a method that adds item to the shopping cart, right? And the AI coding assistant can provide you with one or maybe multiple versions of that solution, and you can sort of choose to accept that into your code. And that tends to be very powerful, right? Because you can get into more complex changes and really drive the IDE in a way that is kind of more aligns to how developers think. But it's a nice complement to the first piece around code completion. Third is test generation. With Gemini Code Assist, you can generate test plans for your code. You can have unit tests automatically created. You can build integration tests much faster. I mean, there's a whole set of different testing scenarios that are made a lot easier. And this is really helpful because, I'm a developer by trade. I've written a lot of code in my day. And one of the things I've found is, people don't necessarily love writing tests. It's not the most fun part of a developer's job. But it is really necessary that we are delivering tests as part of high quality code. And this is something that we can take off the backs of developers by using large language models like Gemini. Now, there's also times that you may be inheriting code, right? So, maybe you're added to a new project and you're taking a look at, how to add a new feature or fix a bug in a new project. And you're kind of just staring at the code going, what is this? I don't understand. What is this thing doing, right? You can use code explanation. You highlight a piece of code and say, explain this, right? Or go into the code chat interface in the IDE and say, can you explain to me what these two modules do and how they interact with each other? Because it's not clear to me from reading the code. And the language model understands exactly what's happening. Gemini can provide a response back to you that can really help you accelerate how you get up to speed on a new code base, something as developers we do very, very often. Now, Code Assist does all of these capabilities, but it does so in a unique way because it's built on industry-leading Gemini models. And so, in fact, we actually use multiple models on the back end of our serving stack. So when you send a prompt in through Gemini Code Assist, we kind of route that depending on what the prompt is, depending on how much context you need, depending on how fast your latency requirements are. You have a kind of like a matrix of different models that we use in the back end. And all of that is to make sure that you as a developer get the best possible experience of using an AI coding assistant. So, for example, doing code completion, as you're that type ahead, the latency is super critical. You don't want that to be slow, so we're routing to models that are appropriate for that. Now, In Gemini Code Assist, users can specify prompts in many different languages. I've got some of the languages up on screen here, and we can output in a wide variety of programming languages. And these are things that the Gemini models have been trained, thanks to the great work of Google DeepMind, which is the AI research group inside of Google. And we also work very closely with Google DeepMind. In fact, it's one of the unique things at Google that we get to jump on calls together, the folks in cloud, the folks in the developer tool space, with the researchers who are actually building the models to help increase the rate of improvement across all these languages and all these coding assistants. And it's been great in India to hear the feedback from everyone that they are seeing that Gemini Code Assist is in fact one of the best coding assistants. I think what I've heard is the best coding assistant at handling internationalization scenarios. So very excited that that work seems to be resonating. Now, those are the table stakes features. I want to move ahead for a minute and talk about some of the more differentiated capabilities that we have. And the first is something called code transformation, which allows you to analyze, refactor, and optimize your code in a matter of seconds, right? And this is a capability that is unique to Gemini Code Assist. I definitely recommend trying it if you haven't. The second, and this is kind of related to that last capability as well, is something that we call full code base awareness. And this is where we go from contextualizing not just on a few files, that are open, let's say, in your repository, but giving you the entire repository as context into Gemini, so that you can get code suggestions that take your entire repository into account, right? I mean, how many of folks in the audience are working on really big code bases today, right? Okay, I'm seeing a lot of hands, right? Sometimes as a developer, I love working on small code bases. It's easy to fit inside your head. You understand everything. Maybe you don't need a Gemini or a equivalent tool. But when your code base is really big, it's very difficult to reason about it, right? You're as a developer, you're almost building up this tower in your head that is a model of the entire code base. And if something interrupts you, that model can kind of tip over and fall. You got to get back to it, right? That's really challenging to do. So having full code base awareness in Gemini Code Assist allows you to break through and lean on an LLM and lean on Gemini to really do the hard work of understanding the implications of a big repository. One change here impacts all these other parts of your code base, and that is something that is very unique to Google's AI and how Gemini Code Assist works. Now, full code base awareness is only made possible because of Gemini 1.5 Pro, which is our latest Pro model. And this is important because this capability that we have inside of the IDE is directly related to capabilities that are coming out of our Google DeepMind research team. Now, why is this interesting? Well, it offers a 2 million token context window. And that's just what we have working officially right now. We actually have up to 10 million tokens in research. And as you can see, like if you look at some of the other models that are out here, the context window size is nowhere near what we have in research today, and this is pretty special. So what does this mean, right? Like okay, it's a number, context window. Well, what it means is that we can support up to 100,000 lines of code in a single prompt and response. 100,000 lines of code. This stretches the limits of what's possible. Now, when you think about that, coupled with the code transformation capability that I was talking about, analyzing, optimizing, refactoring code, this brings a substantial leap in AI assistance quality, and it opens the door to lots of different use cases that you could have never imagined before. So this is something we're very proud of, and something that we've been really excited to engage with customers and partners. It's been a very big topic of discussion while I've been meeting with folks here on my trip to India. Okay, now to show a little bit of this, I'd love to welcome Roman onto the stage to do a demo of code generation with full code base awareness that takes advantage of our large context window. Roman?
Commerce website application. So as you can see, it's an entire repository with client server side, and there's lots of files or code that's out there. And before we jump into the demo, I'd just like to show you what this application is doing first. Just take a demo of that, and then we'll take a look. Okay. Sorry about that. And then we'll take a look at what it means to add a feature to that. So I'm just going to switch over to the browser. Give me a minute. Okay. So here's the application that's running locally. I've started the server locally on my machine. So this is an application that, as I mentioned, it's an e-commerce site. It's got sample products that are listed. And you can see that if you go into any of these products, you will also see sample ratings, testimonials given for each of the products. So you can see some of the ratings, 4, 3, etc. Right? Now it's powered behind the scenes by this API, which returns back the attributes which are shown over here on the product listing page. Now, one of the things that you will notice is that while we are showing a few attributes like price or availability, we do not have that average rating, maybe as 3 stars or 2.5 stars, whatever be the calculated rating. So that's the feature that we want to develop out here. And that's precisely what I'm going to try out, with our Code Assist. And keep in mind that because it uses, the Gemini Pro models with the 1 million context, it makes it easier to look at the entire code base and then give us suggestions. Now, before we jump into the prompt, keep in mind that a change like this would involve, server-side changes because we need to compute the average rating, return that into the API, and it also requires client-side changes because we need to then, incorporate that change. So obviously, what we are going to be expecting from Code Assist is changes across multiple files and also across multiple languages. So I'm going to switch over back to, the Visual Studio Code, which has got Code Assist and everything installed. And I've got the local servers, as you can see, running. I'm just going to go to the Code Assist chat window out here. And this is where I'm going to give out a prompt that just describes the feature, and then we'll go through that. So I'm going to type out the prompt out here. Say I would like to add a feature to display the product rating on the product list page. So that's, I'm describing the feature at in some way. Then I'm just even specifying that since we saw it's in the testimonial, so the rating is the average rating of all product testimonials. I'd like to use even the star emoji instead of just a value, so let's even specify that. Please use the star emoji to display the rating and show us the changes on both the client and the server side. I'm also just going to, just let it give us a little bit more explanation of what's a high-level approach to do it, and then the code changes. So I'll just say, please show us a high-level, approach to make these code changes, and then display the code changes for each of the files, right? So I've just created this one large prompt, and I'm going to send it over. And remember, if you wanted to do this, which in Code Assistance, which do not have a large context window, it's possible to do that, but you'll have to go through it file by file. You'll have to understand the relationships. That's probably going to, take quite some time and is much more error prone. But here we've given a single prompt, and we are expecting changes to be, suggested to us both on the client as well as server side. So as you can see here, we've got back a response. And like we mentioned that first, let us know about the approach to do that. So it's mentioning that, okay, we're going to be calculating some average rating, and then we need to serialize it because we need to pass it back, to the UI. And then on the client side, it's obviously giving you a few suggestions around taking the average rating and displaying it. But now let's look at each of these files and what's it suggested, and we'll try to incorporate and see if those changes do work. So first up, it's picked up the files and it's telling you that that there's a serializer. Let's see what it suggested. It's telling us to, let me just see if I could. Okay, it makes sense. So from a suggestions perspective, the first thing is around serializers. And let's see, so it's computing an average rating over here via a method that's provided. So let's sort of incorporate that into the file. So I'm going to go to the serializers file, and as I'm putting in the changes, okay, there's average rating. This looks good enough to go with. This is just a serializer part. I'm going to then take in this method, which is computing actually from the testimonials. As you see, it's figured that relationship between the products and testimonials too. Let's take this function. It's got some logic around the emojis too. Let's go with it for a moment. So I'm just reducing a font a bit for now so that I know where to put the code. Okay. So I've just made right now the changes for the server side. Obviously, on the client side, also it suggested me some changes. For a moment, I'll just switch back to the browser where I have the API. And here, if I just do a refresh right now, oops, I missed out something. Okay, so I forgot to make a change. It's my mistake. So product serializer, and yeah, it's given me some changes, but obviously I should have maybe even added this because this is the whole serializing part. So let me add it. Now if I refresh this, as you can see here, now it's got the ratings, right? So for each of the products, we've added an additional field too. Let's switch back to the changes that it suggested for the client side, right? And it's telling you go to the product list page. There's probably some existing code, and it should ideally be showing us some sort of a rating out here. So let me see where that is. It's probably over here, as you can see, the item.average rating, an additional field that is telling us to add. So if I go to the products list, maybe I'll just zoom into the place I need to make a change. So discount price, inventory count, yeah, I could put it at any of these places. So let me just take this piece of code and carefully put it somewhere, let's say, oops, over here. Sorry, I didn't copy that. So I'm going to take this and put it out here. I'll just save this. And now if I come back to the UI, see it's refreshed it because the server is continuously checking for changes. So this was how the Code Assist helped us with the 1 million context window of Gemini to suggest us changes for both the server side. We made changes to the API, we serialized the rating, and it also suggested us changes for the UI, which made us show these ratings over here. Now keep in mind, it's not just for adding features. You could use this full code awareness for many other tasks, including understanding the code base, maybe moving it from one framework to another, maybe a language version, bumping it up with specific features in the newer version of the language. So you could use it for any of these tasks, which would definitely be a lot more simpler than trying to understand each single file and what changes to make, etc. So that was a demo that I had for full code awareness, and how with a 1 million context window, these changes are made possible. And remember, if the context was not that large, it would have been not possible for your assistant to actually use all of these files in the context and give you the suggestions. Thank you. Over to Gabe.
Thanks so much, Roman. I love that demo. In my discussions with customers and partners while I've been here in India, many folks want to migrate, as Roman suggested, from one version of Java to another, and that is something full code-based awareness is very capable of. Does it make for the best demo, though? So I think we decided to go with this. Thank you again, Roman. So rather than generating one module at a time like you're seeing there, you're getting a prompt or a response back from the prompt that includes changes across lots of different files. And again, that's only made possible because of the Gemini 1.5 Pro model and thanks to integrated into Gemini Code Assist. Okay. Let's talk about another feature, and this is something very excited about, and it's come up in basically every conversation I've had with customers and partners here in India, which is something that we call code customization. And specifically, this is around getting AI assistance that's customized to your specific enterprise and whatever the code base is that you're working on. I would imagine many of you are using or maybe have even written your own internal libraries and frameworks, right? Maybe you've written some microservices. Maybe you have your own internal logging library. Maybe you've got a little data access layer that you use to connect to a private database. None of that code is in the foundational models from any provider, right? But it's relevant, right, to what you need to write in as your job of building an application, right? And so what we've built is a capability for integrating all that custom code into Gemini Code Assist in a way that the responses are going to be contextually relevant. Because again, what's the point of generating code if that code doesn't comply with your internal standards? Now, one of the things that's very cool about this as well is this integrates with lots of different code hosting repositories. In essence, we can reach out from Google Cloud and securely get access to code that is hosted on GitHub, on GitLab, on Bitbucket, and make sure that we're able to index that code and surface that code back to you inside of suggestions in Gemini Code Assist. This is it is the most asked for feature that I've heard from enterprise customers, and it's something we have a lot of folks using in production today. So very excited to show you how this works. So for that, let me welcome Roman back on the stage to show you code customization in action. Roman?
I'm going to show you now, the code customization demo and how you can use Code Assist to get, suggestions or recommendations from your private code base. Before we get into the demo, I'd just like to set the context in terms of how we are doing this demo here. So, for example, the Gemini base models, they would be trained on most of the popular, languages, frameworks, and also sample code, but definitely not, code from your private code bases or customer code bases, right? So, just a show of hands, how many of you have heard about this framework, Hyperdiv? Quite a few, right? And that's pretty much what we expected. So what we've done is that we've taken several repositories of code which uses Hyperdiv, and Gemini has not been trained on it, right? So we wanted to demonstrate this in this manner so that then you can see if the suggestions that are given are specific to Hyperdiv code also. And how have we set it up? So I'm just switching over right now to this Google Cloud Console. And as Gabe mentioned, right, we connect to GitHub, GitLab. So in this case, what we've done is we've created connections to several GitHub repositories which have got Hyperdiv specific code. So some of these which you see over here, they've got several projects which are in Hyperdiv framework. So and then what happens is that behind the scenes we ingest each of these repository codes, we index it, we host it in a tenant for you, and we securely expose that to the Code Assist endpoint that's there within your VS Code environment, so that the suggestions that you will get would be specific to this. Now, before I show you the demo, just wanted to tell you that in case you just use without the code customization feature and you start coding in Hyperdiv and you expect certain suggestions to come back, you would not get any suggestions. But in this case, since we've ingested this, created an index, and the endpoint is available out here, we will see that it gives us suggestions, both even from a local context which could have Hyperdiv code as well as the indexed database. So first up, just let me show you what the application in Hyperdiv, the current one is about, and then we'll add features to it. So here's a pet registration app, and as you can see, you can put in a name, and it shows a list of pets available for adoption, etc. But we've not sort of built out some features. Like, for example, I would like to add maybe some radio buttons which could say, it's a cat or a dog, maybe a add button that could then add it to the list, etc. So I'm going to switch now to build out these features, and I'm going to go back to my project out here that's there. Now, the servers anyway started, which is what you saw the application. Now, this is all Hyperdiv code that's already there, and I've created these code, comments, which we'll be using to then send it to, Code Assist to give us suggestions from a Hyperdiv code perspective. So we need that kind of code to be generated. So as you can see, there are 3 points over here. I'm just going to add the features one by one to it. So the first one says about adding 2 radio buttons to choose between a cat and a dog, because right now I pretty much don't have that over here. So when I go for code generation, this is where it's going in and it's making a call to the endpoint there. And what we should be expecting back here is, as you can see, it's given you Hyperdiv specific code now based on the repositories which we had made available indexed. So we can accept this suggestion right now. And if we just save it, you can see that those live changes are happening where we've got our radio button that's added. But pretty much it doesn't do anything. So the next submit button, the next piece of code to generate is a submit button. I'm going to go for that too. And again, it uses Hyperdiv specific code to do a submit button. I'll save that, and you can see that it's there. But pretty much, if you give a name and, that's my pet dog. So if I try to add, it doesn't do anything here. So I'm going to go to the last, code to be generated, which is when the form is submitted, add it to the list. Let's generate that part too. So this is again all Hyperdiv specific code, and I'll just save this and tell you another interesting part of this also. I'll just save this. So as you can see, it's taking in the names and then it's adding it through a local method that's out here. And now if I try to, it's working, and maybe I'm making a cat, okay, and that's working right now. Now, the one thing I wanted to just add over here is, you can see that it not just got the code suggestions, from the Code Assist, the backend which is exposed, but it's also picked up, what is called some local method. So in this case, I have local add registration method, so it's even been able to go in and get this method correctly suggested. So it's taking the best of both. It's not just getting you the code that's required for Hyperdiv, but it's also picked up any local context of the code also and given you that together. So that's what I had to demonstrate how you could use Code Assist to get recommendations from your private code base and thereby boost developer productivity to another level. Thank you. Over to you.
Thanks so much, Roman. And it's great to see the code customization in action. And I think it's also a really good reminder that, I know a lot of developers today are using like chatbots and kind of interacting with chatbots as their main mechanism for getting code suggestions. But when you see that, particularly what Roman just showed there around the use of that add registration method, it shows how, it's really hard to cut and paste all the relevant context into a chatbot and make sure that you're getting the coding assistance that's correct. And then you add code customization, right, and connecting repositories that might have best practices, that might have example code that you really want to make sure you're incorporating. That makes it this IDE-based experience with Gemini Code Assist really the best bet for developers looking to use generative AI. Okay. And one other thing that I'll mention is this is all Google Cloud grade technology. So a lot of folks will be like, oh, wait, you're going to index code? That's kind of core IP. Yes, but that's all done inside of secure virtual private cloud networks. It's all single tenanted, it's isolated, and so there's a whole bunch of security controls around that. We work with a lot of financial services customers who do this, and if it works for them, I'm pretty sure it would work for all of you as well. But yeah, again, this is thanks to the power of Gemini, but also the power of Google Cloud being used to make something like code customization not only possible, but also secure. Okay. Speaking of customers, Gemini Code Assist is used by several leading customers from around the world, and they're really folks who need that kind of enterprise-grade feature set, and they appreciate the quality of the responses and the productivity gains that they're seeing from the use of something like Code Assist. All right, now, Google Cloud is committed to building the best coding assistant for developers. And this mission is not just about technology and models and IDE integrations, right? Although that is a big part of it. It's also about integrating with the community. And you're going to hear from some folks from our partner community today. But we've also built some partnerships with lots of organizations and an ecosystem of organizations around Gemini Code Assist. Last year in December, we announced a set of partners that were going to be working with us to enhance Gemini using their documentation and their knowledge sources. These partners, they worked with us on ways to share data and make sure that we were able to incorporate the best practices of their products into the code suggestions that come out of Gemini. Right, so this includes partners like Sneak that do inline code security scanning, partners like MongoDB, Neo4j, and others who you're going to hear from today. They've worked with us to enrich their content, and looking forward to showing some of that later today. Now, one of the key tenets that we have in our product strategy for the teams that I manage is making sure that we meet developers where they are. And that means inside of the tools that they use and the platforms that they know and love. So we offer AI assistance across the entire developer tooling ecosystem. So for example, you're seeing a lot of demos today in VS Code. We also support JetBrains IDEs, and we're bringing Gemini to popular platforms that millions of developers use. Platforms from Google, as well as from other partners like JetBrains and Replit. And this allows us to provide coding assistance in a lot of different services, and we'll talk a bit about some of those now. So how many people here are familiar with Colab? From Google, yeah? Wow, it's a lot of hands. I love Colab, right? Managed notebook experience in the cloud, really important for the workflow of building generative AI applications. And Colab Enterprise brings the popular version of Colab that you've probably experienced into a version that's powered on Google Cloud that combines the ease of use that you know and love with Colab with an enterprise-grade security and compliance regime provided through Google Cloud. Now, with Code Assist, Colab developers can benefit from code generation and code completion inside of the Colab experience, right? And so this is really helpful. And if you haven't experienced this, I would definitely encourage you give it a shot. It sounds like a lot of Colab users here in the audience. We also offer Gemini assistance inside of Android Studio. And so this allows you to get your standard coding assistance like you're seeing in Gemini Code Assist, but it also adds Android-specific domain knowledge to make sure that we're giving you the most accurate guidance for building Android applications. And all this is integrated natively inside of the Android Studio workflow. We also are able to leverage Gemini's large context window inside of Android Studio as well, very similar to what you're seeing with Gemini Code Assist. So you can really use both. If you're familiar with Android Studio, you can get Gemini support there. If you want to build inside of VS Code or inside of JetBrains IDEs, you can use Gemini Code Assist and get the same experience inside of those environments. So really providing you a lot of choice in that regard. We can also help build and explain build and runtime errors along with suggested fixes. This is an area where we're moving outside of just the inner loop of developing code and also able to help analyze errors that are happening at runtime and provide you assistance on how to go back and fix those errors. And that's a unique capability we offer inside of Android Studio. So something pretty unique about that experience. Now, similarly, we've launched Gemini inside of a Firebase, and what this allows us to do is provide a great experience for AI-assisted development for the web and mobile apps that developers love to build inside the Firebase platform. This works inside of the Firebase console. It works inside of Crashlytics, and you can get really great summaries of like why are things crashing, and get suggestions to help you go fix things that you're finding inside of the runtime environment. So it's a really terrific solution, and we have some great demos of this, but we didn't have time to run through those today. All right. So yeah, I just want to kind of round out a bit here with why Gemini Code Assist, because a lot of folks I work with, I spent a lot of time at Microsoft and worked closely with folks on the GitHub teams and elsewhere, and I hear a lot of, well, why Code Assist versus GitHub Copilot or Cody or a lot of other solutions that are in the market. And let me just kind of run through this quickly. Well, first of all, we're the only coding assistant that has full code base awareness powered by the Gemini 1.5 models. And hopefully today you understand why that's so important. We also didn't talk about RAG and large context window as an enabler to better RAG experiences, but that's also another key reason why long context window matters. The second is that we do the industry's leading research on developer behavior. We run something in my teams called DORA, which is a set of DevOps research reports that is around measuring end-to-end developer productivity, right? And there's a set of DORA metrics that we use to kind of measure how well our software team's performing in the art of delivering software and managing and maintaining software over time. That research is run out of my teams, and we make sure that what we're betting on the product side and the innovation that we see happening in the market, that we're also being honest with ourselves and with the community about, are we seeing the impact in terms of like what those AI-assisted features are actually delivering. And so that combination of the products that we build on the GenAI space plus the research arm is very unique inside of the industry today, and it really helps keep us honest and with a high integrity as we approach innovation in this market. Third, we are the most enterprise-grade coding assistant in the market, bar none. Google Cloud's security posture, enterprise compliance, it's unmatched in the industry overall. And then lastly, we have the most ISV integrations in the industry. Other providers in the space are very good at integrating a single tool chain. We work with a lot of different partners because we have a vested interest in doing so and making sure that we have a whole ecosystem that is helping make Gemini Code Assist as relevant as possible to as many developers as possible. Okay. The second thing we're going to talk about is we're going to quickly cover how we help build GenAI applications faster on Google Cloud. That was all about productivity. Now let's talk about what you all are probably building in the audience and how we can make that better with Google. So what are the essential building blocks for building GenAI applications? Well, first of all, you're going to need some model, right? Second, you're going to need to connect that model to your data because you don't just want generic responses coming out of the LLM. You want something that is unique to your business. And then third, you're going to need a place to deploy and run the application in a way that's going to allow it to do the inferencing and access to your data, right? Pretty basic, but still some decisions that need to get made here. So what does this look like? What does this application architecture look like? For that, I'd like to welcome Abhirami onto stage to show you what a RAG-powered application looks like powered by Google Cloud. Abhi?
Thank you, Gabe. Reloading a few things. Timeout things. Thanks for the placeholder music. All right, we're all set. We've learned a lot about building with generative AI today. Now I'm going to take you step by step through a hands-on experience where we'll build an AI-powered shopping assistant for our e-commerce site. It's called Symbol Shops, as you can see right here. And to build this, we are going to leverage our Gemini's multimodal capabilities. And let's dive right in before going into the actual implementation or seeing how it has all come together. We do a prototype. So let's go to Google Cloud Console. Let's go to Vertex AI. I'm sure you've all seen this. And then go to the multimodal overview page And let's go ahead and type what I want to search for here. So basically, this is a shopping assistant. So I want to upload an image of my living space, and I want to ask questions about how can I furnish it with rugs or chairs, what kind of bookshelves will go nice in this room, and questions like that. But before that, I just want to make sure that I have the right model and the right attributes and parameters set. So I'm just going to try out a prompt, and the model that I've chosen here, which is hidden in the tab, is Gemini 1.5 Flash. So I'm going to say, take a look at my living space in the image and describe the style of the room. Right, so here is my media. I'm going to upload the image of a living room. And there we go. The reason we also want to do, like I said, is to finalize, to narrow down on the model that you want to go ahead with, and also to align with the attributes and the parameter settings that you want to do. So you prototype before you get started. And we have the response, and it looks pretty great to me. And I'm going to take a note of this, which I already have, so that we can come back to it at a different time. So here is a detailed explanation of the design of, or the space itself. So now let's go back to the code that is actually powering this shopping assistant. So like I said before, we are using Gemini's 1.5 Flash, and we are also using LangChain, which is a super popular framework for building with generative AI. So the first step, what we saw in prototype, thanks to LangChain's support for Vertex AI and Gemini, it's less than 5 lines of code to accomplish that. So let's see how we have done it. As you can see right here, we are unpacking the user's prompt into a variable called prompt, and then we are instantiating to invoke the model Gemini 1.5 Flash, and we are also taking the prompt that we already stored and separating the message, and we are taking the base64 of the image, and we're invoking the model right here and returning the response, which is basically the description, which is what we have in the prompt context that we have set right here, and we are returning the response as a dictionary result right here, and that's what we store in description response. From this point, it's pretty straightforward. We know that we'll take this description, convert that into embeddings, and compare that against the embeddings of the products we have in our catalog, and then do a vector search, that is similarity search on top of that, to find the most relevant, the contextually relevant matches to the user's ask. So it's pretty straightforward from there. We'll look at it. But before going to that, since I mentioned embeddings, I want to show to you what embeddings look like in case you haven't already encountered or used this in your applications. So for this, I'm going to take you to AlloyDB Studio's query editor. So I'm right here. I have the query, a simple query that's already ready. And remember the prompt, the response that we got from the prototype. So I have it ready right here as well. And this is a simple select query at this point to invoke text embedding Gecko 003 model on the search text, on the description text that we got, and I'm converting that into embeddings. So, sorry, I just selected something, I guess. 1 second. Let me run this. There we go. So this is exactly what embeddings look like, if you haven't already seen. So at this point, we all know what we're going to do. So before seeing those steps, the vector search part and then bringing it all together with Gemini, I also want to show to you how all of this comes together and how this works for specific needs for the user. So here is my application. I'm going to go to my chat assistant, if this is okay. So let me just type in my request here. Here is the image of my living room. Typo. Recommend matching sofas or chairs. Choose file. I'm going to choose the same living room and send. So if you notice right here, not only is it going to bring out, it is able to understand, sorry, it's a bit zoomed out, yeah. Not only is it able to understand the context, understand the image, and bring the pieces together, it is also able to bring out contextually relevant matches which match the room. At the same time, it is also actionable. So I click that, I go see the product, I get the details, I add to cart, and I can even place order. This is not for me, for sure, but I can place the order if I want, and I can continue shopping. But how did we do this? How did we go from taking the embeddings and getting the responses? Any clue? The keyword is, as we all know, RAG, right? Retrieval Augmented Generation. So the first step with that is to retrieve. So what exactly are we retrieving? As you can see right here, we have our vector store. The vector store is in AlloyDB. So why AlloyDB? Because it has a familiar PostgreSQL structure, SQL syntax, and also it supports, like all other Google Cloud databases, it also supports AI, the generative AI capabilities that we need to use. In this case, it's similarity search in place, which is inherently it supports. So we're using AlloyDB vector store, and I'm making a synchronous call to that. As you can see right here, it takes the description field and it converts it into embeddings, which is already there. We already have done this, and we have stored this in AlloyDB. We are just referencing to that in this particular step. From this point, it is, like I discussed before, it's straightforward. We're going to do 3 steps. One is to convert the user requests and the image into description, convert that description into embeddings, do a vector search, and lastly, ask Gemini 1.5 Flash to make sense out of all the responses that the vector search has returned. See if the the contextually relevant responses are really what the user wants to see, and then return it to the user. So that's all. So let's see how we have done it. Step 1, as you can see right here, we already went through this part of the code where we take the user request and convert it into description. So we'll skip past that. We'll look at the second step, which is actually taking that description, adding some more context, adding some more prompt relevance, and then we are calling the vector search. At runtime, this is actually being converted into embeddings, and it is performing vector search with the vector store that we have already seen, that we've already stored in AlloyDB, and it returns the contextually relevant docs, and that's what is happening right here. And finally, we are taking all the contextually relevant docs that vector search has returned, and then we are passing that to Gemini 1.5 Flash, and then we are making sure that the responses are in fact grounded in the catalog products, and it has all the details that we need for the user to make action on top of it. So that is exactly what we're doing right here. So now that we know how it works, now that we've got all this covered, let's just take a look at another example. I just want to find rugs maybe this time. So here is an image of I should have just kept the chat open, but I closed it. Living room, recommend matching rug or rugs. Let's see what it brings up. Okay. There we go. It also describes the ask. It describes the room at first, and then it comes up with rugs that are matching the needs. And like I said before, you can always open it, view the description, view the details of the product, go ahead and purchase it, and continue shopping. So there we have it. We have gone from no generative AI, no RAG component, to a completely RAG and generative AI-driven shopping assistant in just a few clicks and a few steps. And if you are interested in what you just saw, the code is available in Google Cloud Platform's GitHub repository as microservices-demo, or you can always talk to any of us about any of these services that you're interested in. Thank you.
Thank you so much for that, Abhi. It's really great to see in action, right? Like an application that just uses an LLM, marginally interesting. An application that uses LLMs that's grounded in your enterprise data, now that's really, really powerful. And these are the kind of applications that most of the customers I talk to are trying to build today. So, love that demo. Now, you can see though, we were able to do that pretty quickly, and some of that was preset, but there's a lot of technology choices and a lot of ways that you could kind of build something like that. We have a huge evolving space. There's many models that are out there. We have model gardens and model hubs. We have orchestration frameworks. There's different vector databases you can use, including many options on Google Cloud. There's options for fine-tuning. There's lots of different technologies in this space. And to be honest, sometimes it can be a little overwhelming, right? Where do you get started, right? So let's talk about that for a minute. We at Google Cloud have aligned on a simplified approach here, and this isn't going to work for every scenario, right? There are going to be cases that are going to make sense, where it will make sense to stray from this. But if you're just getting started, we recommend starting with Gemini models, including models that might have support for large context window. We recommend AlloyDB, as you saw, for storing your vector embeddings and enabling these RAG-based applications. And we also recommend Cloud Run as a developer-friendly platform for hosting your container-based workloads that power this kind of application. So let's discuss why we chose each of these. So Gemini 1.5 Pro, I think we've said enough about this at this point, but not only is it long context window, but as you saw in that last demo, it's natively multimodal. And this is something very unique about Gemini, and one of the first models to really offer this capability where images, video, that are treated at the same level as text, right? So these aren't just language models, they're really multimodal models. We also have Gemini 1.5 Flash, which is our fastest and most cost-efficient model. And this is available with a 1 million token context window. So with Gemini, you can build fast, low-cost applications that don't compromise on quality. Okay, fun fact, we know that there are at least 1 million developers building today with Gemini models. In fact, this data is probably already out of date. We're seeing a lot of popular interest in building with Gemini, and that popularity continues to grow. Okay, so while we have vector support across the entire database portfolio in Google Cloud, like you can store vectors in Cloud SQL and Spanner and lots of different databases, AlloyDB is what we selected because it's a high-performance, fully managed Postgres-compatible database. And as a developer myself, Postgres, I know was always popular when I was spending a lot of my time writing code. It's still very popular today. It's only increased in popularity. AlloyDB is based on Postgres, but it offers better performance for these vectorized and RAG use cases. So that's why we're promoting it. And you can't go wrong with it as a database just in general. But not only that, it also offers integration deeply into Vertex AI and into LangChain. So if you are building with generative AI, we've made the ecosystem around AlloyDB equally friendly to use, and this can help jumpstart your journey. Okay, so why Cloud Run? Well, with containers and Kubernetes as your base, you can accelerate your AI journey without having to reinvent a wheel. I'm sure many of you today, actually how many, I'm curious, how many of you today are using containers or Kubernetes? Yeah, just about every hand goes up, right? And so if you haven't used Cloud Run yet, I definitely recommend giving it a shot. It is by far the easiest developer-friendly platform for building and running and managing containers. You don't have to worry about managing infrastructure with Cloud Run, but it works natively if you need to move that workload into a Kubernetes environment. The container form factor and sort of the overall model works very well with what you might otherwise be using in your enterprise environment. So you can't go wrong with Cloud Run. So, in conclusion, I want to leave you with a few thoughts. This GenAI shift is a big deal, right? It's changing a lot of things in the industry. It's changing the way that companies are thinking about innovation. It's changing the way that developers are writing code. It's changing the way people are thinking about running and operating code. There's a lot of disruption and innovation simultaneously happening in the market today. Google Cloud wants to be your partner in that transformation journey. We want to work closely with all of you in the audience, all of your friends who weren't able to make it into this tightly packed room today. We want you all using and working with Google Cloud and with Google technologies overall to help go from where we are today to the bright future that we have ahead. Now, there's a few ways that we're going to help you with that. First is we want to make it really quick for you to get started building GenAI applications. We're going to provide everyone with easy and flexible tooling to use, and then integrate, as I said before, with a very broad and very rich ecosystem, because that's what developers need, is they need access to a range of technologies not built just by a single vendor. So One thing concretely that we've done that's been very popular, and some of the demos actually reference this today, is something that we call Jumpstart Solutions. Now, these are fully integrated stacks of software that you can go to the Google Cloud, navigate to the Jumpstart Solutions page, and get a generative AI document summarization application, right? And it's all working. It has all the infrastructure, has all the source code. It's all wired up and ready to go. And what we find folks doing is using that for learning, right? You're never going to use probably that app as is, the document summarizer, but you might want to understand how a document summarizer works with Google Cloud Storage, with Gemini, and using that app and learning from that app, maybe having Gemini Code Assist explain the code inside of that app. That's something that can really accelerate your journey as a developer, so I recommend you check out those Jumpstart solutions. We're also integrating, as Abhi said, with the AI ecosystem. LangChain is integrated deeply with Google Cloud databases. You saw a bit of that in that last demo. We also have LangChain integration with Cloud Run, so you can easily run a LangChain application inside of Cloud Run. There's a natural one-gesture integration to get a container running inside, a LangChain app running inside of Cloud Run. We also have been working very closely with the Hugging Face ecosystem, and so you can get one-click model deployments from a Hugging Face into Vertex or into a GKE cluster, and this really helps for folks who are interested in exploring lots of different models and are maybe users of the Hugging Face platform today. We're empowering developers at Google Cloud with a balance, a very careful balance between choice. We want to integrate with lots of different tools in the ecosystem. We want to provide you lots of different stack options. We want to provide you with solutions regardless of what your skill level is. But we also want to provide innovation that is unique and different at Google Cloud, whether that's full code base awareness or large context window support or the work we're doing on code customization, which is very unique and differentiated in the industry. This balance of choice and innovation is central to our philosophy of how we're going to be building products at Google Cloud. All right, and so with that, it's no wonder 90% of generative AI unicorns, companies worth more than $1 billion, are building on Google Cloud today. This is very important. Why are they building on Google Cloud? Well, it's pretty obvious, yes. So as all of you look to build the future as well, you're in good company with 90% of these unicorns who are also Google Cloud customers today. Okay, so the last thing I want to mention is we have a GenAI Exchange hackathon coming up, and we've done months of planning on this. The team's done a great job. This is around working with Indian developers to solve for some of the biggest challenges that we see inside of the Indian market today. And so we're thrilled to announce the GenAI Exchange hackathon, supported by Mady, I think, Startup Hub, and Startup India. And so what's very cool about this that I learned is this is around trying to solve some of the biggest challenges that CEOs are seeing in the industry today that they think could be helped with GenAI. So here's a couple problem statements. So for Policy Bazaar, this is sort of in the insurance space. The idea here is how could you use generative AI to build a human-like agent that can really revolutionize the insurance experience, right? And so that's, I think, an interesting challenge that will be addressed in the hackathon. Another one is from Network 18. So how could you develop a solution that enhances the trustworthiness of video content? Very interesting. Also, maybe a great use case for Gemini's multimodal capabilities. So these are the kind of problems that folks who are involved in that hackathon are going to be able to work on, and looking forward to seeing participation from folks in this crowd and beyond. All right. And with that, I'd love to create some time for questions. Do we have a little bit of time left for questions? 3? Okay, so I would love to get a few questions from the audience. Yeah, we got one over here, please. Actually, I think we wanted to get a microphone. If you'd wait 1 second. Oh, this one, here.
Check. Hey, Monroe. Welcome to India. Thank you for this opportunity. So my question is that code assist is really cool. Okay. Assume I have one GitHub URL which had a fantastic code. I don't know either it was may suggest in the process or not, but I would like to give that URL and ask the code suggest from this particular URL's code. Is that possible?
Okay, so I think if I'm understanding the question is, you don't necessarily have the code, but you have a URL, and you wanna incorporate that URL into a suggestion. Is that right? I haven't seen that use case yet. I think the way that would have to work is the model would have to kind of browse to the URL and kind of download the content. There are maybe some issues around that with having our models go out and reach out and grab information from different websites could be a legal or compliance challenge, and I think that might be part of the reason why we haven't done something like that. But definitely something I will talk to the team about and make sure I'm understanding exactly where we're at on that capability. But for now, I don't think that is something we are able to support. Yeah. Yes.
Thank you. Hey, I'm Pramod. I work for Wipro. We spoke about a lot of code bases and all, right? But my question is, see, I work mainly on the package tools, like Oracle middleware or SAP kind of thing.
Yep.
So how can generative GenAI help package tools to come up? Like, for example, if I have to just do a version upgrade, I have to spend 6 months from start to end to upgrade all my environments and all. So how can it disrupt that kind of setup?
And could you give me an example of package tools, like what kind of?
For example, like Oracle Hyperion, EPM products, or Axiom, or for example, board planning and budgeting tool. These are all already like built-in tool where we customize for the customer requirement.
Got it. Yeah. And I don't know the specifics of those tools, but as you can tell with Gemini Code Assist and the related tools, we're really working on programming languages or configuration languages that can be edited inside of an IDE. So if one of those package tools has a language that can be edited inside of an IDE, it is possible for us to help with that kind of AI assistance in that way. We may not yet have training data to do a good job on some of these, and so that's something that we're looking to improve. And in that case, I'd love to understand more about which specific package tools we could help you with. Specifically the ones that have code. If they don't have code and they're more of a visual editor experience, more of a low-code type of environment, that's something where it's going to be a little bit more challenging because the UIs tend to be something that aren't an area that Google controls. So it's possible that we could look at extension points on those things, but normally I would expect for the tool developer, Oracle, potentially, to build their own GenAI assistants in that area, and hopefully if they do that, they work with Google Cloud and Gemini to do so.
Hopefully. What happens is, people who work on these package tools, we kind of feel left out with all these different, developments happening around in the environment right now.
I totally understand that feeling, right? And it's challenging, right? Because these low-code solutions, part of the reason that they're so exciting is they're really easy to get started and they're really easy to edit. And if everything works just inside of that tool the way you want, it's great. But when ecosystem starts to innovate, GenAI starts to come about, AI coding assistants, sometimes you can feel left out in those environments, and that's a bummer. But it may be possible for us to help if those tools can compile down to a lower level language.
Thank you.
Yeah.
Okay. Am I audible? Okay. Thanks for the wonderful demo. So I work for 24/7 AI. We build AI products, right? Now, what are the platforms available for the developers today? There are many developers, they cannot spend money on the Google Code and spend, evaluate the models and everything, right? So is there any evaluation platform or SDK platform or developer platform, basically, where we can play around with the models and learn about and then experience and then get into the production, right? So is there anything?
Yeah, it's a great question. And we are very mindful of making sure that we provide access and ideally free access to get started with learning some of these technologies. So for example, AI Studio is a great place, Google AI Studio that is, to go play with Gemini today. And you can do that for free right now. Also, Google Cloud itself has $300 in credits that are available for folks who are signing up. And you can get started. You can do a lot with $300 of sort of trials. Also, Gemini Code Assist, I believe we are still running a promotion where that is free for the moment. So I think even with Code Assist, you can get going for the moment without having to purchase a license. And we're also looking at other ways, let me just say, to make this technology more broadly adopted. So hopefully all that will help. All right, everyone, I think we're out of time here, and we have some other great speakers that we're looking forward to. Thank you so much for attending today. I'm hoping you found what we shared valuable today, but also hoping that you're going to find a lot of value in the sessions to come. Thanks, everyone. I look forward to being back in India soon.
Hello. Thank you, Gabe. We would now like to have Shayak over on the stage. Shayak is from Adya. He's the founder, CEO, and CTO of Adya, and he's going to share about Adya, the platform is built, and how we are partnered with Google Cloud to build that. Shayak, thank you.
Thank you. Can everybody hear me? Okay. So first of all, I'm a little low on energy today because I haven't slept the last 2 nights. So if I say some things or I slur some words, I'm sorry. Thank you, Gabe, for that very, very interesting presentation. I'm going to talk less about us and what we do, and a little bit more about what we did with Google Cloud. And this is so interesting, and I'm genuinely saying this. This is so interesting. We love the work that we've done so far. How do I move forward? Okay. Yeah. Where do I point this? There? Which one do I press? Oh, that's the one. Sorry. Okay. A little bit of our own drum beating. We've got a lot of big enterprise customers in India who are building using our stack. I'll talk about it later. Okay. So we started off with this. I remember I came back from Next in Las Vegas, and Google had just unleashed using, how can you build applications using AI? And it was new to me. We already had a team that was very fast, very good. We were building applications, really good, high-quality applications in less than a month. And I saw this, and in Vegas, I was talking to so many developers. Someone was saying, we use Vercel V0 for the front-end coding. Somebody was saying, we use Gemini Code Assist. So we had a whole bunch of different conversations. And what we were doing at that point was we used to go to the ChatGPT interface, copy some of the snippets, put it back, and then try to correct it. So I said, that can't be the optimal way to code. So we have to figure out a better way to do this. And so June, we started experimenting with this. It was a lot of work initially because those days there wasn't a very good set of documentation guidelines on how exactly do you go about creating this. And so we went about this process, and the first application that we built, it was a lot of fun. We actually built a demo trading application using AI, entirely using AI, all the way from scratch. And funnily, it outperformed the market at that point. Okay? So we were actually making money, paper money, not real money, but we were using the trading app. It was doing algorithmic trading, which, by the way, isn't really allowed in the Indian Stock Exchange. So we couldn't practically use it, but we were testing it for. And so what we did those days, the first step was we were taking the screens from Figma, entering it into Vercel V0, and after we entered it into Vercel V0, we took the code, and we had integrated Gemini Code Assist into Visual Studio Code. And so inside VSC, we were using, so we actually went to the Gemini Code Assist dashboard to create the entire BRD first. The whole business requirement documentation was created inside Gemini. We did experiment with Claude, ChatGPT, everybody, but we figured out that if you use Gemini end-to-end, you get better results compared to doing piecemeal in different places. So we ended up, and remember, again, I'm talking about June. Right now, our process is far more evolved. I'll talk about what we do now. So we went to Gemini Code Assist, the main dashboard. We created the entire BRD with the functional documentation, et cetera. We then gave it to Vercel V0. We got some of the screens, et cetera. We took the code. We put it back into VSC. Once we put it back into VSC, what we did is we asked Gemini Code Assist first to optimize that code. So funnily enough, we were putting code, and Gemini Code Assist was also generating code next to it and telling us the difference between the two, and telling us how better optimized code can be done. This is something you don't get if you use something like a ChatGPT interface, et cetera, to just download the code and then copy it and put it here. So then you're still optimizing it yourself. So we found that to be a huge benefit. Then what we did is we asked Gemini Code Assist to start documenting the code. It did all kinds of documentation, line-by-line documentation, overall documentation, the DFDs, the data flow diagrams, et cetera. It did a bunch of stuff. And we found it very interesting. So then we asked ourselves, can it actually do architecture? Can it build those databases, the DB schemas? Can it do it? We were using Postgres those days. So we said, OK, let's try. It actually gave us very good ones, obviously not entirely accurate because it didn't have our existing code in it. So we said, OK, let's optimize it, et cetera. After that was done, then we said, OK, now let's create the backend code. And when we started doing that, that's where we faced some difficulties. Because the code it was generating, the logic wasn't 100% accurate. So we realized what we have to do is we have to feed it the older code, the ones which we have already written. And once we started putting in our existing code into it, it started generating things which were almost as good as our senior developers could do. And it cut our development time down by massively, like huge amounts of improvement. And we were already in July by the time these experiments were being run. So we had already built 2 apps by that time using AI entirely. Because I dedicated a small team, 2-3 members, and I said, we will basically learn how to code using AI before I involve the entire team into it. And so we were running a lot of experiments every day. I personally used to go, and I used to look at the code, and I used to say, how can I improve this more? What more can I do? And then I said, OK, can we do unit testing? Can we do automation testing, regression testing using it? And that's where the context window became very, very important. Because as soon as we could give it the entire code base, it was doing the debugging like on the fly. It was giving suggestions, et cetera, inside VSC, which was very, very important to us. Because remember, as a small startup, we don't necessarily have full code reviews all the time. And a lot of the bugs are found out when it hits the market. Like, of course, we do a testing, and we do a whole bunch of things, but we're not necessarily doing regression testing, which requires a lot of effort. Like, if I want to do a 90% code coverage or 80% code coverage, I don't have the bandwidth to do that. Absolutely not. Even though I'm building enterprise-grade products. So this made a huge difference. I found out a tool, because that time Gemini Code Assist didn't used to give that off the shelf. You had to create some kind of backward integrations inside VSC. Now that comes off the package. But those days, what we did is we found a tool which was doing it inside VSC. So somebody had created some kind of a solution for it. So this is the process we went through. The entire BRD planning, scope definition, objectives, goals, et cetera, 100% done by AI, to an extent where our project planning improved dramatically. I was talking to my project manager, and I was like, what exactly are you guys doing? Why is it going so much better now? And they're like, we didn't tell you, but we're using AI to do the project planning. So essentially, it was difficult to measure how much time each part of the code would take, what happens if some redundancy happens, the entire process of measuring the time to complete something. So we were very good any which way, but there was a lot of push and pull between the front-end team, back-end team, DevOps, and QA and everything. There used to be a lot of push and pull. That kind of reduced drastically where things were moving very seamlessly. And we were wondering, and rather I was wondering, as a CTO, what is going on? Why is it how did my team suddenly get so much better? And I realized that the planning was done to the nth level. It was actually very detailed. And that entire planning had been done by AI. It hadn't been done by the project managers, which is a dramatic improvement because in a small startup, the project managers also double up as a product managers. So they don't necessarily have the time to write BRDs and project plans and everything in thorough detail, right? So we did all that, the scoping, everything using AI, and then we went into the requirement analysis. By the way, the requirement analysis, we found a very, very good use case there. So we used to record the customer conversations using a tool. And so we found a particular tool. Here we didn't use Gemini Code Assist because I don't know whether it's built for that. I've not tried using it for that. I use something called MeetGeek. And MeetGeek, I found, is an exceptionally good tool. What it does is it literally records a conversation bullet by bullet. From this time to this time, you spoke about this. This is the insight. This is what your action items are. It was a lifesaver. So I took that, and I put that entire thing, I automated the funnel, put that entire thing into Gemini Code Assist, and so the requirements flew into it, and it created the BRD by itself. This was brilliant, because it saved me so much time. I basically took, it used to come to me by mail, but MeetGeek also has an API. So I connected that straight into Gemini Code Assist. So the whole BRD came to me from the scratch, without the product manager having to go and talk, without me having to sit down and explain to the team, this is what I want. Normally, what I used to do is I used to do scratch pads, I used to do Google Sheets, I used to do the diagrams myself and set it for them. Now, it did all of that for me, because obviously I set out the prompt in the beginning, what exactly I want in it. So when MeetGeek's entire recording, and I should have kept a recording of it here, I wasn't prepared for this today, but essentially MeetGeek gives it in a absolute detail, really good detail. And when I pass that into Gemini Code Assist, it understands that and creates a BRD just like that. And it's a very good BRD it's creating, right? So once that is done, then the design part, this part I still feel can be improved to an extent, because some of the design work, I mean, yeah, sure, you can go into the chat window and you can start talking about it, that put a buffer around this, or make this color, etc. But in reality, how we develop is we need the screens, right? So that part we found that Versal V0 does to an extent if you give a copy of the screen that you want. So supposing there's somebody who's already built something like that, you take a screen grab, you put it into Versal V0, it creates that. You have to obviously pick it up and put it back. And then the designers obviously do the Figma part of it very, very well. Okay, so we did that. And as I mentioned, the entire development part, today, the way we are developing, even then we had saved about 70% time. Today we are about 2 times faster than even then. So June, July, whatever time we used to take, we're about 2 times faster than even that, because what we figured out along the process is you can actually build one module and give that to Gemini Code Assist to learn what you're doing, and it builds other modules very, very accurately, instead of asking Gemini Code Assist to build from scratch. That actually saves you tremendous amount of time, front and back and everything. And then obviously I told you what we did for testing. One of the things we haven't figured out is how to connect it with Cloud Run. It's something that I'm actually planning to do. So basically Cloud Assist, not Code Assist, so that's something we'll be getting into. This is actually what I wrote at the beginning of this. This is just a screen grab of that. I actually created this process. So you'll actually see my dev team leads, names, etc. here as to what they have to do, and this is a real one. This is exactly how we do the development now, okay? By the way, this is interesting, because I had created the AI and the human, who does what, done that. So this is very interesting, because my team actually follows this, in case you want to take a screen grab. Okay. Yeah, so I created this. I haven't updated this. So we are now about 2 times faster than even this. So this I had created in July, this particular thing for another GDG event where I was speaking. Since then, I haven't updated it. But it actually saved me a tremendous amount of time. I was measuring in that testing period, how much time does it actually save? You will not believe, I'm right now trying to create a platform to enable GenAI developers to connect different LLM models, create their own agents, and then connect it to their existing app stack, whatever they have. I'm trying to create that entire platform so that they can create their own agents, the multi-agentic architecture. I literally gave my team 2 months to build the entire platform. It's because of this. And they're delivering it on time, almost on time. Okay. It's never on time. So, any questions before I go into what we're doing? Any questions on how we are using or how we are leveraging AI? Any specific questions that anybody has? Yes? Can somebody give him a microphone? Oh, yeah, sure. Yes.
Framework sort of stuff you are building, so because this is too good, right, for any of our developers to adopt.
Yes. So, okay, so let me understand your question a little better. Maybe keep the microphone. So, are we using a framework or are we building a framework?
No. Whatever you have so far done is the day-to-day work for Adobe developers, right?
Yes.
It's like 5-member team, 6-member team, or
yeah,
20
5-member teams can build entire platforms now. Forget products.
That's where I'm coming to. Right
yes.
now, there is a 20-member team, a 50-member team doing this,
yeah.
and it's manual.
Yes.
And right now, there is an approach going towards that, where on bits and patches, I'm doing this with the GenAI. Now you have a full, complete story.
Yeah.
Maybe this is a good use case which we can framework it and utilize it across the developer community.
I
This
mean,
is
I'm
just a
happy to
thought.
discuss that with you
I'll
because
take
I
it up.
built it for my own use case. I used Gemini Code Assist to build a sales AI also, which does all my sales for me. Literally,
Fantastic.
I'm not joking. I don't have the salespeople. So what I did is, I created my ideal customer profiles. I gave it to that. It goes and scrapes the internet for the right profiles, and then uses a LinkedIn connector to find their contact details, goes and hits zoom in for rocket reach for their phone numbers, email IDs, creates a CRM by itself, and then creates a right communication messages for each one of them. My team obviously reviews it before it goes out. I've got just one person doing it. And then after that, when the responses come back, there's another automation funnel for it. So I believe in these kind of things. It just makes a lot of sense. I really have saved a ton of effort. I mean, Angad is there. He's sitting there. Angad, if you don't mind standing up. So he's the one who's running that sales AI. He's my co-founder. And the entire sales AI, now we are generating about 50 leads a day with one person, the entire process. So, you can do obviously that's not Gemini Code, that's Gemini Core. So we've done a whole bunch of things like that. Any other questions before I move on? Yes, please. There.
Can you please talk about a little bit your infrastructure as a code and, how do you maintain, the DORA metrics, especially how do you monitor the performance of your infrastructure and your team who is maintaining the infrastructure as a code?
So that is the one part. That's a very, very good question. Thank you for putting me on the spot. That's one question I don't know the real answer to. I'm trying to figure out. That's what I'm saying. So it's a good question. What I'm trying to do now is I'm trying to put observability metrics around it. And I'm trying to ensure that, so just to put things in perspective, the way we build the platform is using, everything's automated using a node layer on top, and underneath is all Terraform scripts. So because we automated everything, there is almost no breakages, because nobody does anything manually, and everything we do is in a UAT environment. But what my main concern is, during build, there are problems. And there are problems as to, just why is my server not whitelisted? Who put that VM on? So that goes on, even now. So I'm trying to optimize that, and you're right. I know that Cloud Assist could do some of that, and I've been a little busy building my new platform, which is one of the reasons I haven't gotten around to it, but it's a good question. Something I should figure out. There was a question from back there, yes. And this is probably the last question I'll be able to take. I don't have too much time. I'll take your question too, sure. Let him finish, and then I'll take your question.
Thank you. It's a really very good use case. I was just thinking about the prompts that you might be using at different stages, just to make sure that hallucination does not happen.
Okay.
So how did you take care of that part?
Okay, so, there is no one answer to that. It's actually a sequence of things. So when we're doing on the fly, obviously, there are certain prompting frameworks that we're using at this point, which we figured out works very well. But then there are also automations that we've set in place, which always uses the same prompt, because there is a certain amount of predictability you need in certain use cases. So we're doing both. So when the developer is developing the backend logic, et cetera, that's one part of it. But when the QA is doing it, when the team lead is doing the unit testing, or when they're looking at code optimization, those are automated. So I'm not necessarily using one kind of prompting. But yes, there are certain prompting logics which we use, too difficult to discuss in this, but that is there in place. We're kind of creating a documentation around it right now. Yes.
Much for sharing so many details. It's really exciting to see that you're saving more than twice or more time about it, but how you're handling the safety posture of your application, security piece of it, which is also equally important. As you mentioned that you are directly copying, pasting the information. So
we don't do that anymore.
Oh, okay.
So you're right, and that was one of the problems that used to exist. Validations, security, especially because a platform like us is entirely built on microservices, which is then terraformed and which is then launched uniquely in each client environment. So if the environment values, et cetera, are not properly set, there's a whole bunch of security issues. And we were kind of struggling with it. We were big time struggling with it. So this is, genuinely, I should have pointed it out. This is probably the biggest saving of if you use AI for coding. Gemini Code Assist, when you're giving it those prompts, no, you're actually checking. You're asking it. So when my team leader, before they move it from UAT to the prod environment, they actually have to run these, and some of these are automated, as I was mentioning. So they are actually checking for all the validations are in place or not. They're checking if all the backward integrations are in place or not. They're checking if all the ports, etc., the way we've set it up is properly done or not. So now, I mean, obviously, this is not going to pass a very deep security audit, but it is going to pass almost any security, because last few months, I've enabled it for some of the biggest one public sector bank. I mean, I can't go deeper than that. And they haven't found an issue. So it's actually doing a great job. Those are the kind of places where you really want AI, because it can't miss a single thing. And checks. It checks line by line and gives you where things could go wrong. Okay. I'm going to talk a little bit about what we do, just so that you guys know. So at Adya, just a little background about me. I'm an ex-Indian Navy officer, retired lieutenant commander. I used to be a nuclear, biological, chemical warfare specialist, a helicopter operator, and one of the youngest officers in the history of the Navy to make it to staff rank. I left the Navy in 2012. I ran a few hotels and restaurants by the beach in Goa, and then I went to France. I did my MBA there at INSEAD. Post that, I went to Germany. I joined a company called the Rocket Internet Group. I used to be the global MD across Latin, Africa, South Asia, China. Then I stopped doing that, and I said, I'm going to do something of my own. I went to a dormitory in Hyderabad, started a company, expanded to Singapore, Middle East, and then US. And then 21, 22, I was in US. Then I said, the market's getting really tough. So I dropped that, came back, and I started Adya. And what Adya does is it runs two platforms. I'm going to talk only about one of them today. And this is an India Stack platform. What this means is, you know how the government is coming up with all these protocols, ONDC, Honest, etc. Now, somebody needs to create a plug-and-play app stack on top of that. Because everybody's creating their own version of the apps, which are not necessarily very customizable, very composable, very scalable. And so what happens is you as a small business have to go sell on that or buy on that. But if I'm an enterprise and I want to launch, or I'm a mid-sized business and I want to launch my own applications, it becomes really difficult for me to do that, okay? So in very, very deep collaboration with Google Cloud team, what we created is an automated app builder. An automated app builder. This is not an account that you have on an existing platform. This is PaaS. This is a platform as a service where you can go and say, I want a retail application. I want a logistics application. I want a mobility application. I want a credit or an insurance application. I want an education or a jobs application. So all sorts of applications, there are about 16 of them, which you can build in 1 hour, ready-made. So it comes with, I'm going to move on from here. By the way, this is a very interesting thing. I'll talk about it. But so you can go to Atma, and Atma stands for Atmanirbhar Technology Marketplace by Adya, ATMA, and I jokingly call it, Bharat Ka Atma. So the point is, you can actually go there, and what you can do is you can launch your own application, which will come ready with all the integrations with the banks, payment gateways, email, SMS providers, which can be launched on multiple different clouds, which can be connected to your existing stack however you want to, everything, and you can obviously customize it however you want to, ready-made. It's a ready-made app builder, right? And it's very important. So these are all the domains that we cover as of today, the various domains on which you can go and build your applications. So anybody building a buyer application, who would essentially build a buyer application? Somebody who already has hundreds of thousands or millions of people coming to their applications on a daily basis. A buyer application is a window. It is not an application where the products are there. It's a protocol, okay? Now, the difference between a platform and a protocol is the platform, so think about it this way. The easy way to think about it is, imagine you go on Amazon to buy something. You're also on Amazon. The seller is also on Amazon. So when you search for something, you don't see a result from Myntra. You don't see a result from Swiggy. No, you only see the result from Amazon. But the beauty of a protocol is, think about the internet. There are so many browsers on one side and so many websites on the other side, right? So I can go to any browser and all websites will show up on every browser. There's no exclusivity. Same way, if you go to a buyer app and you search for something that you want to buy, any product or service, I could be buying insurance, a loan, I could be buying food, I could be buying cars, jewelry, anything I want to buy, a flight ticket, whatever I want to buy, the buyer app doesn't have it. The buyer app simply broadcasts the message to the protocol, and every application on the other side that is registered with those products and services will automatically send their data to the buyer app. So you could be buying insurance inside Uber. You could be buying jewelry inside Ola. You could be buying food inside Google Pay, and it wouldn't matter, because none of those applications themselves are selling any of that. They're just windows, just like the browser is a window, right? So obviously, small businesses benefit tremendously from this, because they don't have to go and sell on 10 different platforms. They register on one seller app and become visible on every buyer app. So not a problem. Costs go down. Everything is very, very good. Enterprises benefit a lot, obviously, because I build an application, I can bring my whole ecosystem into that application, right? Problem is this. There are more than 16,000 companies in India today trying to build an application. 100 are live. See the problem? Why? Because it's incredibly complex to build these applications. And that is where building an open tech stack on top of these India stack protocols will enable anybody to build that application. That's the point. That's why we created Atma. Yeah, that's about it. Any questions on ONDC? I'm happy to answer one or two questions, then I'll have to go. I think I'm out of time. One question can I take on ONDC? I'm not on Atma, by the way. I'm not going to answer questions on Atma. Done. Sure. Thank you very much.
Thank you so much for that. Thank you, Shayak. Thank you for that inspirational talk. We will have the next set of speakers on stage. Ail, why don't you come over? But again, thank you, everyone. Shayak will be outside. You can also interact with Shayak after some of these sessions. Help him with that. So you have seen what we can do with Gemini, with Code Assist, building GenAI apps on Google Cloud. You have one of our customers here talking about what they have done, right? And it's been really inspirational to see how they've used Gemini Code Assist to build their applications. We spoke about the hackathon that is there. Shaik spoke about some amazing tech that he has on offer that you could use to build out your applications with the hackathon. So look at it. Gabe also spoke a lot about some of the ISV partnerships that we've been having, right? So we are working very closely with a whole bunch of partners. And while we have shown you a simple stack that you can build your applications on using Google Cloud, you also have your data and your applications running on other platforms, right? So what we have now is we have 3 of our partners who will come on stage one after the other, talk to you about their platforms, how you can build applications with their platforms, with their products, and use Gemini and Google Cloud to build the same. Okay, so first we will have Ail on the stage from Neo4j. That will be followed by Karthik from Elastic, and then finally we'll have Babu from MongoDB. Ail, whenever you're ready, you can get started. While Ail is setting it up, are you good?
Start up with the presentation first and then...
Yeah, please, go ahead. Again, I know you all probably want to have your lunch as well in due time and then go on to the workshops. So let us take all the questions after this. We'll have the three of them come over, showcase how you can actually build your applications on their products, integration with Google Cloud. All of them will be outside as well, right? So we have some tables outside for networking. After this, we go into lunch and networking. So please ask your questions at that time so that we can maintain time for the rest of this and go into the lunch and workshop.
Oh, nice.
Awesome. Ale, over to you.
Awesome. Yeah. Thank you, Prashant, and thanks, Shayak, for the inspirational talk. I really enjoyed to know what Adya was doing. All right, without further ado, let me quickly dive into the presentation. So my name is Elil. I work as a principal partner architect with Neo4j. I enjoy hiking and badminton. And by the way, this is what a graph representation of my bio looks like. So Neo4j is a native graph database, and it stores the data in this manner. So we don't, all the circles that you see are called nodes, and then the lines or edges are called relationships. Then this is my LinkedIn in case you want to connect with me. You guys are no stranger to graphs. So how many of you have heard about Neo4j or any graph database already? Wow. So for people who are new to a graph technology, you guys are not stranger to graphs. In fact, in any movie that you have seen so far, this kind of scene usually comes there, where the protagonist usually goes through connecting all the peoples and places to find out to clear out a murder mystery or find out a criminal. And that is actually a graph. And not just that, the internet is actually a big, huge network of connected information that is going on. And similarly with molecules, so all the pharmaceutical industries think in terms of graphs to find out and uncover new compounds. Any metro network or a transportation network is actually a graph. Similarly, nowadays all the financial transactions are actually thought out in terms of graphs to find out, to uncover fraud ring that is going on there. Not just that. So you also have a lot of militaries nowadays coming up with defense ops plan like this. This plan is actually from the US invasion of Afghanistan long back. And ever since, a lot of operations plan are done in terms of graphs. So your business too is actually very interconnected and very, very evolving. So organizations are always fluid. It always evolves. You have a lot of customers, suppliers, and products that you have to deal with. And a lot of interrelated relationships are going on between various entities. So in order to have these interrelations, you have to be very flexible with your data schema. And that is what graph technologies are here to help with. And often, valuable insights are located in these relationships. So when you have data in terms of, thought out in terms of a tabular format, you are missing out all these relationships. And if you think in terms of graphs, you can actually leverage them and then uncover tremendous insights from it. So a graph can provide both organization and context. So your data is actually stored in this manner, like whatever you see in the yellow nodes over there. And you catch the relationships between all these entities in your data. And the relationships give you more context out of it. And there is an organization of or semantic principles on how your data is actually organized. So this, if you model your data in this way, in a way you can, it's very easy for the human beings as well as the machines to comprehend what is going on with your data. So a short intro about Neo4j. Neo4j is inventor of labeled property graphs. We have been in this space for like more than a decade for now. And we have a strong funding in terms of, in one of the largest fundings in database history. We have a very strong ecosystem of developers and data scientists. And 75 out of 100 Fortune 100 companies actually use us and trust us. So we started as a native graph database, a pure graph database. And then over the period of time, we started adding in a lot of graph data science algorithms. So these algorithms help you to quickly do in-graph machine learning. So that means you don't need to move the data out. You can do everything. You can call an API, run one of these algorithms, gain valuable insights, and then store it either in the database or you can export to some other data stores that you have. Then you have Bloom, which is our data visualization or forensic tool, which helps analysts to find out, say, go through your data, uncover a fraud ring, and so on. And the important point here is that we are not there to replace, Neo4j is not there to replace any of your existing systems. If you have a SQL or a NoSQL systems, they are meant for different use cases. Whenever you want to find insights from connected data, that is where you will use Neo4j. And we have very good integrators to move the data around between these systems. And similarly, if you have, say, a Looker dashboard, you can connect with Neo4j to build dashboards out of it. And these are some of the subset of algorithms that we have. Few of the algorithms here are very powerful. Like, for example, graph embeddings are powerful in converting, say, your graph into something like a vector embedding so that your traditional models can understand. So in a way that you can keep on using your traditional models, which are very tabular based, and add these new features from a graph embedding through Vertex AI feature store or somewhere, and then start using in your existing models. And within the Google Cloud ecosystem, Google Cloud portfolio has, especially the database portfolio, has a wide variety of databases that you have. And Neo4j is there to complement as a native graph database there. And in terms of integration, we are very well integrated. So if you want to move your data from BigQuery, Spark, or any Kafka-based systems, you can very easily do it. And you can run your machine learning workloads from Vertex AI and then integrate with Neo4j. All right, so let's move on to GenAI and what knowledge graphs have to do in GenAI. So the challenges with GenAI nowadays is that, a lot of people try it out and then they say like, yeah, it's good for demo, but what about in production? Usually that is where a platform like Gemini is there to help you. Later on I can show you how Gemini can make you take a demo application to production in a matter of few minutes. And throughout your journey from, say, demo to production environment, you have to think a lot of challenges as well. For example, if you're taking a pure LLM and then trying to use it in your production system, it lacks your enterprise domain knowledge. And you have to have a mechanism to verify whatever answers that these LLMs provide you. And obviously, there are a lot of problems with confabulations or hallucinations. You have to think about data governance. Say if you are training an LLM with your internal employee data that has salary information in it, and you don't want everyone to see each other's salary information. And that is where you have to think about data governance, as well as obviously ethical and bias concerns as well. So why you have to ground your LLM? Everyone knows that, yeah, you can fine-tune your LLM, but if you're asking questions, sometimes it may move out of context. And that is where retrieval augmented generation, like what you see here, helps you. So basically, you get, based on the user's query, you pull out a relevant context, give it to the LLM, and then ask the LLM to answer the user questions within this context. And that gives you more accurate and relevant responses. So end of the day, it's all information retrieval eventually, if you think about. And the IR methods in RAG that are popular today are predominantly sparse vector retrieval, like BM25 or TF-IDF, where you use keyword-based mechanisms to pull out the relevant information from your database. And these technology, especially the BM25 algorithm, have been existing for like 30, 40 years, very proven technology, and still it works. And then you have dense vector retrieval, that is where you use cosine similarity, Euclidean similarity, and all those different algorithms to pull out similar chunks from your data systems. And finally, you have graph-based systems, which is good to capture relationships, and it allows for more personalization and multi-hop querying. So the first two methods are good for recall. So if you want an IR system that's good for recall, the first two is good. When you want to go for more precision and control, that is where you use a graph-based system. Especially when you want to answer, say, multi-hop querying, that is where you rely on graph-based systems. And nowadays, the common pattern is that it's a graph RAG or hybrid RAG where you combine all these three together to build better and robust RAG-based systems. You might be asking why specifically a graph-based retrieval. Why so? Because you have vector similarity search that's there, and it gives you relevant pieces of chunks, but you don't have the relationships captured here. Either you have to have the metadata within these chunks and then have to manage them yourself. But in a typical IR retrieval scenario, you have to do some multi-hops to answer specific questions. And that is why you need a native graph, property graph model like this. Say if I'm able to get the first node or a chunk that relates to an employee that the question is about, then I can always have the connected information like the company or the city where this employee is located or working for. So that way, I know a 360-degree view of this particular employee, and that gives a lot more precision and control to your model. This is a very high-level reference architecture that you have for hybrid RAG. Basically, use Vertex and Gemini to pull unstructured data, and then create a knowledge graph, and then you do RAG on top of it. So a typical semantic journey looks like this. So you have vector search on one side, where you go for finding similar documents. Then you have the graph database that provides graph traversals, and finally you have the graph data science. So what that means is that once you have a graph, a knowledge graph in place, you can add insights from your graph data science, put it in the graph, and then help your LLM answer more questions. One example is that you have, for example, you have an e-commerce company that captures products, categories, and brands like you have. Here I'm also capturing unstructured data for my product or customer reviews, and then putting them as embedding vectors within my database. Then you have the GDS algorithm that captures the co-purchase behavior. So how I'm purchasing and how my friends are purchasing. Then you take them and then you put it in the same, enrich the data in the same graph, and finally you get more insights out of it. So here I'm combining both a vector search, and then I'm enriching with the additional insights that I get from the knowledge graph. So how do you do with Gemini? How do you go from development to production? So Gemini provides code assist, which helps you to, like it was covered earlier, so you can use Gemini code assist, integrate with your IDE, go for co-piloting, and then you can run Cypher queries, which is what Neo4j's query language is. You can integrate within Gemini workspace and have it execute Cypher for you, run Cypher for you. Then you have reasoning engine. So there are 4 layers within the Gemini ecosystem. The top layer, the models, the Gemini models, and then you have tooling or function calling. Then you have LangChain for reasoning, and then finally you have the reasoning engine. That is, you move your code to production with all the security, privacy, and observability best practices built in within the reasoning engine. And how do you do it? So you can do it like in 4 lines of code. Like this is my LangChain code that has Neo4j integrations in it, and then I define my requirements here, and that's it. So it gets deployed to the Gemini ecosystem, and then to consume it, I simply have to call the reasoning engine deployment, and then start querying my instance. So this is how easy it is with all the best practices built in. Right. So I'll take a minute to show this demo application that we have. So basically, it takes unstructured data from from SEC, the Security Exchange Commission in the US. Basically, it takes Form 13 and Form 10 documents, which are semi-structured data. So it has informations about a wealth manager buying stocks from various companies, and then I'm feeding it into Gemini, and then Gemini helps me to build a domain-specific knowledge graph here, and I can interact with the graph. So once I have that in place, I can either use a vector-only approach, which is going to be like this, without any interconnections. And if I'm asking any complex questions or multi-hop questions like this, which companies and asset managers are connected to vulnerable to lithium shortage? If my chunks are very, very not interconnected, then I'm not going to get critical insights from it. So that's why my information here, the RAG response here is not so precise. But if I start connecting them, then my information is very precise. It's exactly what I'm looking for, because there is a context out there. The asset managers and companies that are exposed to lithium over there. And then you can also do convert your queries into Cypher and then execute it and then get the database retrieve it for you. So there are various approaches to do it. So in the interest of time, I'm going to stop here. I'll be very happy to take your questions outside once the session is done. And for people who are new to graphs, Graph Academy is a great place to go there and then learn about graphs completely free. You can get even certified, and Neo4j will be shipping you a T-shirt, a better T-shirt than this, to you for free. Yeah. Thanks.
Thank you, Il. We'll have Karthik from Elastic next. Karthik.
Hey, good afternoon all. A quick introduction, myself Karthik Nalliyappan, so working as a partner solution architect in Elastic. Before I dive into the generative AI, right, so what we do with Elastic, just wanted to know how many of you already know about Elastic? A lot of people already knows about Elastic, so I think you know about Elastic as a search engine and then mostly as an ELK stack, as a log monitoring. Let's have a look at what we do with the generative AI, right? So how do we actually meet that conversational search experience? The generative AI is actually driving new opportunities. It's revolutioning every business in terms of providing any code samples or providing some online recommendations and whatever it is, right? So, but then what happens, sometimes, okay, when you ask questions, it can create some hallucinations, right? When you ask domain-specific questions about some organizational policy where the generative AI is actually not going to be trained on, it's still going to provide you all those answers, but then those answers are not going to be correct, but it still might sound confident. And that is exactly where Elastic comes into picture, where if you see it in the left side, the Elastic, which has got access to all the private data, the sensitive databases, the customers' order-related information, kind of chat history, the employee-related information, organization-level policy. On the right side, okay, you will see all these GenAI models, Gemini, Google Palm, the models whichever is actually available on the Vertex AI platform. Now, Elastic will actually act as a bridge between this private data and as well as with the public data. And why do we actually, okay, make Elastic as actually a bridge? Now, the generative AI models can also be trained on all this private data, but think about the efforts that actually been required to train all these generative AI models, right? And then think about the amount of GPUs that's actually required to train these models. A huge amount of efforts required. You would need a big data sets, and then you would need a high GPU cost involved to train these models. And that is where we store all this data, the organization level policies, the private data, and Elasticsearch indexes, connect with Gemini, Google Gemini, to provide a conversational search experience to the end users. And that is where this comes into picture, the RAG, Retrieval Augmented Generation. Now, imagine a situation, a user is actually asking a question about a work-from-home policy, right? So the work-from-home policy varies from organization to organization, and then it also varies from one particular location to another location. It's not going to be same between India and as well as in Canada. Now, when we ask this question directly to the generative AI models, right, which is not actually having trained, for an example, if it's actually not trained on this data, it's still going to give you a response. I'm not saying it's not going to give you a response. The response is definitely going to be generic, right? Not kind of trained on domain specific. And then it's actually have to consume too much amount of data, right? So that's going to go and consume all the information that we have it on the internet to provide a response. Now, in this case, what happens, we store this data, the internal data, into Elasticsearch, be it actually on a PDF documents or images, audio, video formats, or whatever it is. As you know, we store all these things in Elasticsearch indexes. Now, when a question is actually asked, right, it's about organizational policy, we take that query into Elasticsearch, go and look for that information, pull that relevant information and put it in a contextual window. I'll actually I'll actually speak about how do we actually pull out that relevant information. Now, we send these relevant informations in that prompt window along with the original question to Google Gemini, right, to the generative AI LLM models. Now, when we send this one, so what is the benefit of it? We are just going and searching and pulling out that specific information, and then we use the generative AI, Gemini's capabilities to provide a human-like response back to you. Like I mentioned, helps for you to reduce that hardware cost, helps for you to not to train all these models, right? So not to train these models on a domain-specific information, something like a medical records or something like a financial information. How does it actually work? I think most of the people who actually spoke about me talk about this vector search. Elastic, most of you actually knows about Elasticsearch as a keyword search. Now, we do vector search capabilities as well. Now, what happens, okay, we actually store all this data as a vector embeddings into our databases. And then when, when there is actually a query which is actually coming from the end user, that is also will be converted into an embeddings. The good thing about Elastic is we do have our own transformer model, which we call as the ELSA, which I'll talk about it. But you can also load the third-party LLM models also. You have some third-party transformer model from Hugging Face, and you just wanted to use that to transform the data as a vector embeddings. Yes, you can do that as well. Now, we can take all this information, apply a k nearest neighbor algorithm to find the nearest match, right, to give you the more relevant results, accurate results. So what are we trying to do in this RAG approach, right? So why are we using Elasticsearch in between? The one more point that we use Elasticsearch is also to improve the relevance for you, to also to improve the accuracy for you. Being known where Elasticsearch is actually known for this search, we are into the keyword search. We are known for that for ages. Like we are actually known for the speed. We are known for the relevant results that we actually provide in keyword search. Now we pick up that keyword search. Now keyword search, I think most of the developers, as you know, we store all these information to take the frequency of these particular terms or data that is actually available. And then we also mentioned okay, which index where this particular data is actually stored. Known for speed, there for ages, we take this keyword search also and then put it into this RAG model. With that, we use a vector search. A quick example of how do we actually store all these informations. It's actually going to be in a numerical representations. The value is actually going to be less than 1. Store all these things on vector databases. And then the beauty here is, when you actually query this information, right? So when you actually query this information back from Elasticsearch, we apply a k nearest neighbor algorithm, and then you can actually use the Elastic query language to kind of restrict results using some filters. If you look at on this particular example, you ask a question specific about if you want to look at a particular dog images, but you don't want to look at the JPEG images, you just want to look at the images of PNG type. You can actually specify that in the Elastic query language. You can clearly mention that. Kind of you can see, you just wanted to pull out results based on some date ranges. You wanted to pull out results based on some specific type of data, right? So all those things is something that you can actually apply using this Elastic query language as well. Now, what happens, I spoke about the ELSER model that we actually have. So it's actually Elastic Learn Sparse Encoder. So we store this data as a dense vector, and also we can actually store this data as a sparse vector. Now, what is this Elastic Learned Sparse Encoder model, right? So it's actually coming out of the box within Elastic. Now, for an example, if you're taking an LLM model, that LLM model might be getting trained on medical level information, right? So medical records. Now, if you use the same LLM model to query information about some financial data, right? So, or query information about some kind of healthcare related data. So what happens, the performance is still going to drop, right? So it's not going to provide you the relevant and accurate results. The ELSER is actually trained on all those information, so where you can actually use this model for any kind of a domain-specific questions, right? Be it actually on medical records or be it actually for a financial services data. So right now, this is actually trained only on English language, but you get it in out of the box within Elasticsearch. Don't have to use a third-party LLM model. You can use it on the go, right? As being a developer, you can actually load this in just a click of button, and all the data that you actually want to store will be stored as a sparse vectors. So now, Elasticsearch, we have this keyword search. semantic search, we store that as a dense vector, and we do have an option as a sparse vector. You can use a third-party transformer model to transform the data as a vector representation as an embeddings, or you can actually generate embedding somewhere outside of Elastic, and then you can actually store that into our Elastic vector databases as well. Now, when we combine all these things, right, like I mentioned, why do we actually combine all these things like a keyword search along with a vector search to improve the relevance? When we combine all these things, how do we actually rank the results, right? So we actually put a score for the results that is actually been returned by the keyword search, the results returned by the vector search. When we combine all these things to provide you with a hybrid search, what happens, okay, the score that we actually generate for the keyword search is definitely going to be higher. It's going to be from the number one, it's going to be in a bigger, higher value. Now, in terms of the results returned by the vector search, it's definitely going to be less than 1, which means when the results are returned, the results coming from the keyword search is definitely going to be in the first. So that's where we apply this concept called reciprocal rank fusion. We don't take the scoring of the results. What we do is like we actually take the order of the results, the position of the results, and then we combine these two, the keyword search and the vector search, apply a order of the results, apply a formula on top of it to improve the relevance for you. So now you can see it when we integrate Elasticsearch with an LLM model. You can take a benefits of keyword search, you can take a benefits of vector search, the sparse vector, apply this reciprocal rank fusion technology, helps all these things to improve the relevance. So when I actually go and search for the specific work from home policy, it's actually going to look for the results for the particular location, taking that particular relevant contextual results and send that into LLM model to provide a human-like response back to you. With that, I'll just get into a demo. Yeah. So this is a demo fake travel website that we have actually built it. Now, I'm sure you all have seen that normal Elasticsearch experience. Now, this is actually going to be a conversational search experience built using this RAG technique, connecting Elasticsearch, where we actually stored all these travel websites, FAQs on Elasticsearch indexes, and connected Elasticsearch with a Gemini in the backend, with a LLM in the backend, right? Now, there's actually a simple travel websites where people can actually ask questions about their flight bookings, flight cancellations, their travel information like how to hire a vehicle, accommodations, or something like. It can also generate an email for you telling you if you wanted to actually write an email to the customer care executives. In this case, it's actually, my flight is actually canceled. I'm going to use this model to understand why my flight is actually been canceled, right? So, and what should I do if my flight is canceled? Now, if you see it over here, I have it my RAG enabled. Now, the Elasticsearch will actually take this query, look for this information from Elasticsearch indexes, then sends it to LLM to provide a response back to me. So when I click this, I just have this comment sections which is available over here. So when I click this, it's actually generating a response. So you can see how the response is so much precise, right? So it says, if your flight is canceled, you should hear from the airline instructions, or maybe you need to reach out to this particular email address or reach out to this particular mobile number for any help. So what I'm going to do is I'm going to disable this RAG, which means the call is actually going directly to the LLM models. When I do this one, it's still going to generate a response, but you can actually compare the response. The response which I actually got earlier is actually very much precise. It just gave me the mobile number, the customer care number where I can actually reach out to. You can see here, it's still generating a response, but it's not something which I can actually action on it immediately, right? It says contact the airline, review your booking, rebooking or refund, keep documentation, travel insurance and all these things. It's good. It's actually very good information, but still, okay, I don't have the immediate information to act on it when my flight is actually been canceled. So that is the power of actually connecting Elasticsearch with the LLM model. Just going to enable it again. Yeah. So what you can also do is you can actually ask a follow-up question, right? So like, can I get a refund if I actually cancel my flight? So what happens, we actually stored all these refund policies on a separate index. Now, Elasticsearch is actually going to look for these information on a separate index, which means you can store these data on a multiple indexes, and then it's just giving me a precise response. Yes, you can. It's possible to receive a refund if you cancel your flight, and if you cancel within 24 hours booking, this is what you get. You get a full refund, and yeah, blah, blah, blah. All this information is actually required for me, okay, to get it, right? And then what I'm also going to do is like, I'm also going to ask some other follow-up question. Now, I also wanted to know the refund policies for the accommodations as well. You can see here, okay, I'm not asking a direct question like, tell me the refund policies for the accommodation, right? So I'm just putting it like, tell me one for the accommodation. So in that case, yes, the Elastic's AI assistant, which is connected with the LLM model, it actually remembers the chat history. It understands that I'm still asking questions about the refund policies for the accommodation, and then still going to provide a response back to me. And then I can also ask a even more follow-up question, something like, how can I request it? Right? Going to give me clear instructions on how can I request for the refund, for the flight cancellation, and as well as for the accommodation. So you can see now Elasticsearch is actually kind of remembering this particular chat history, whatever the questions that I actually asked, okay, before this particular question, giving me the refund policies information, okay, about for the flight and as well as for the accommodation. Now you can see the difference, right? So without connecting Elasticsearch to LLM, you still get a response. The response is actually definitely going to be generic, not going to be specific to this particular travel website information. When I actually connected Elasticsearch, you have seen, okay, how I got the precise information, right? So yeah, so that's the RAG technology that we have built it over here. So you can actually start using it, Elastic on Google Cloud. By the way, we are actually available on Google Cloud. You can just go and subscribe a trial version of it. You can actually go to our machine learning model to see the ELSER model, and then load the ELSER model, load your documents. By the way, as I think you all know, you can actually use a web crawler tool on our website to crawl information from any website, store that as an indexes, and convert that as a web embeddings. With that, yeah. So if you have any questions, we are going to be there outside. Yeah.
Thank you so much, Karthik. Thank you for that. Again, thanks for explaining the power of RAG, augment your models with that, connect your data to that, and build these GenAI applications. Would like to invite Babu on stage next from MongoDB. While he's getting set up, I'll keep you entertained for a couple of minutes.
Can I have the audio? By the time this, sorry to take you off. By the time this is getting set up, first of all, thank you. Thank you for extending. We totally understand this is a lunchtime. And I'll promise you I'll keep it on the time, okay? And also, what you're going to take out of this session, 3 things. What is MongoDB for? How we work along with GCP or the Google Clouds to get our solutions. And 3, some of the samples where you can readily take it out and you can put it across to your customers. And talking about MongoDB, I hope, can you just raise me a hands and say how many are familiar with MongoDB? Fantastic. That's a great show. Okay. Now, most of you know MongoDB as a NoSQL database, but with Atlas as a provisioning, which I'm going to talk a little bit later, we are expanding. We are bringing the application towards the database, and you can sort of build your applications, build your charts, build your complete suite of business requirements with Atlas as one one stop for any of the solutions there. Having said that, we are also ventured into the vector store and vector search. And I would promise, like, so far we have discussed about what is RAG, how vector search works and all. I have cute 2 or 3 slides for you to understand how the internals of it's going to work, how it's going to transfer the data from your either a document, PDF documents, or in terms of any other stuff to the vector, okay? So let's start the session. Basically, this is the agenda I spoke about. It's more about how it is MongoDB, how we are working it out with GCP. And in terms of collaborations, we have around 37 plus regions on GCP. You can host the MongoDB Atlas cluster free, no credit cards. So it's a lifetime free, but it comes with the basic unit of a M0 cluster, which is sufficient enough for you to build any of your ideas or your thought process to a software. And it's easily for you to convert those things. With Gemini now, it's easiest for us because we have something called MQL, MongoDB Query Language. Now with Gemini Code Assist, that's also made easy. So you have something as an idea, or you are a customer looking for something as a part of a requirement, you just go to Gemini, build a query for the MongoDB, and just push it across to your free cluster, test it out on your own laptop, and then bring it out as a production version. All these are in a single click, single glow. You don't need to sort of invest time as our earlier stages like, oh, I'm a Java expert, I'm a Python expert. That layers are breaking out. Apart from that, we have various integrations. I'm going to give you one slide at the end, which is going to give you a complete GitHub repository. So feel free to use it up. It's a free license. So that's about what we have with the integrations. Let's quickly jump about what is Atlas's platform we are doing. We are calling this as a developer data. Oh, sorry for that. We are calling ourselves as a developer data platform. It's for some reasons. So far, we were there in the NoSQL only database lanes. So we are expanding our horizon. As I was telling, we have some sort of application services. We have something for the edge computing. We have something for the geospatial. We are very well versed with the time series. We have some use cases in terms of all end-to-end of it. And important point to talk about here is this is all well secured within the network, within the Google Cloud networks. You can transact the data. Moving across, this is our entire platform in a nutshell. So we have, in terms of, we are specialized in OLTPs. We are the number one, or I would say like one of the topmost databases in your OLTP regions. So in that, we have basically a document-based model. And many may be hearing it out as a myth, like we are not ACID compliant. We are ACID compliant. So anybody who wants to sort of deep dive on this, who wants to take it up as a special requirement from their customer, we are available outside. We can take it up in a deep dive discussions on this. So we also have something in terms of application-driven analytics or intelligence. So what it means in a nutshell, so I have a mobile app or I have a desktop app where I need to sort of give a customer live real-time data analytics with Gemini's Vertex models. We are leveraging the entire end-to-end data flow. And a customer, let's say, for example, insurance customer wants to know, like, am I eligible for an insurance? So on the spot, in the real time, you can replicate the data. You can go back and tell the customer, say, yeah, you are eligible or you are not eligible, and why you are not eligible or why you are eligible with the data points. You can go back. Entire thing within the enterprise level. I want to also emphasize at this stage, now we are in a generative AI era where the POC sort of, or the demo sort of things are moving out. We are going into enterprise levels. In fact, we have deployed this GenAI models in multiple enterprise applications, which leverages the benefit of the actual GenAI. I'm going to show you a couple of examples also on that, where you can sort of leverage it back to your customers. And this is in terms of what we have in as a connectors. You name any connector, we have it in that so that the data flow can be seamless, and you can transfer from any part to any part of it. So now let's come to the interesting part. Earlier, Abhirami also talked about RAG. We had something in terms of showcasing what is RAG and all. So what it basically is. With GenAI, initially when it comes with OpenAI and chatbot and all this stuff, it's all over the internet. And there was a movement to, or I would say like there was a motion how we can leverage this within the enterprise. And that's where RAG comes in, retrieval augmentations. So what it basically does is, while the GenAI is building an output for you, we are providing an internal context, the context which is very relevant to your enterprise, so that the answer, the outcome which comes out of it is very relevant to your enterprise. And the main key part is the entire enterprise data is secure within your network. So that's how we are moving towards. And in that process, MongoDB created a vector data store, because most of the enterprises GenAI are based on RAG. And this is how it's going to work when I say it is a RAG models, okay? So basically, that's the first part is an embedding. What it means, again, you transform a structured or unstructured data with some sort of an embedding algorithms into an array of data. How it's going to look like? So this is your source data. Maybe it can be a text, it can be image. With multimodals, you can do it with a single multimodal now, single for embedding stuff, and it transforms to an array of data. So that's how it looks like. So you have a text model that's given as text model, but nowadays you have multimodal available. You can bring anything in terms of getting it one shot. So that's, I've given it as a segment. One is text, one is video, and one is the audio. So think of a use case like anywhere
you have some sort of unstructured data and you want to build a use case on it. Let's say, for example, I'm coming, basically, I put my first 10 years in automobile industry, and I clearly remember a gentleman who used to do the endurance test for the engine. What literally he would do is, he's around 40 years of experience in that industry. He just walks by when the engines are running. By the hearing of the sound, he will be able to tell you what is the complexity in that engine. And that's exactly what we are trying to mimic. So with an audio, with a past history of the data, what relevance it makes with this sort of unstructured data. How we are doing it, this is how we are doing it. So in terms of the data, how it's stored internally, it classifies exactly to each of the areas. Like in this case, man related to man are stored in a separate cluster or array, or separated by dog also. So in terms of very relevant to the attributes, so again, it matches this. This I'm giving you in a 2-dimension or maybe a 3-dimension one. Think of a multi-dimensions model. So what level of dimensions we have? We have around 4096 sort of dimensions. So far, vector database from MongoDB can accommodate into this. And we also have some sort of customers which already we have started working across. Maybe if anyone is interested, again, I'm stressing, come back, we have a deep dive discussions on it. So this is how it matches the, when you're trying to go and query on the vector search, which is a semantic search, it's how it's going to query the relevant data from you and bring back the data back as a result. So the next question comes, okay, we have multiple vector databases. Why I need to pick a MongoDB there? This is the key element which I would say, like, why you need to pick a MongoDB. One, we have a combined data source. When I say combined data source, so far you have all your operational data. And believe me, anybody who has already worked on GenAI, GenAI is not a separate standalone, right? You already have an application. You are going to build this application features with GenAI, which means you already have the data. You have to leverage the data along with your vector search or the semantic search part of it. So we give you a provision of single data store, whether it's a geospatial, whether it's a time series, whatever the format of data, you can store it in a single area, and you can combine your lexical search and a semantic search with a single MQL query. And again, thanks to Gemini, we have this query built just by giving you a simple one-liner command. We have something in terms of incremental update. So once you create the vector store, as and when the data comes in, you don't bother. We will build the entire embeddings. We will build the vector store, and we will keep the security and your compliance as how much you are doing it with the database. The same will be applied for your vector data store also. And in terms of coding effort, we are just building this entire thing into a Gemini assisted. So you go and go into the Gemini code assist, type out something, you will get the code entire thing with your MongoDB structured MQL status. And with the adoption within the enterprise, so we are extending in terms of the performance. So we have something called workload isolation, where you have a separate node created for your specific semantic search, so that if you have a volume of search, that can also be managed easily. In nutshell, it completes your architectural complexity drastically down. So this is a slide about how we go ahead with Google. So it's more about we are leveraging the power of data processing from Google and the models. We don't have our own models. We leverage across the Google platforms for the models. And it's a seamless deployment. We have reference architectures, which we can show you at the end, where it talks about end-to-end applications, where you can build it out. And nothing more to say in terms of security and monitoring. It comes as a part of the platform. So again, one slide which you want to give it in terms of how your vector embedding of MongoDB with a RAG, along with the Google Cloud of Vertex AI, whether you want to build an application of generative AI with LLM or SLMs, or in terms of a Gemini code assist, how you can leverage this in terms of building the code. So just a nutshell, these are the entire areas which we can work. We call ourselves as a multi-purpose database. You can apply MongoDB across multiple domains, whether it's a retail or automobile. We have use cases to demonstrate the performance, as well as in terms of why customer adopted this. So you can take this as a reference to your customer and deploy it across there. So this is, again, a few snapshots which you can take it up if you are trying, if you want to have a hands-on, or if you want to try it out as a new models within your organization's showcase. This is more about a prediction score of a movie. So there is a movie database, and you want to sort of predict what is that it could give you as a score for this. I'm not going to go with any of the demos. I would prefer you guys putting your hands on and getting it out. These are all some of the sample repositories. Refer back to GitHub, which is MongoDB-partners. That's the resource where we have the entire models available. Whatever I spoke about GenAI and non-GenAI use cases, we have it. And for those who are there as part of the startups here, we have Atlas. We have credits for Atlas on Google, so you can leverage some of these items on that also. With that, thank you. Thank you for your time, and I appreciate your time for this. We'll catch back later.
Thank you so much to all the speakers, attendees. I am filled with immense amount of gratitude to each and every one of you who are here in person and also on the live stream. I request you all to just quickly take a moment to fill out the feedback form. You can scan your badge as well. There's a QR code on your badge to fill out the feedback form. I'm just going to step aside so you can scan this QR code or the one on your badge. Please do fill out the feedback form so we could improve our event experiences for future, and let us know how you found the sessions today. All right, just a quick note of gratitude to everyone who's joined us on the live stream. Thank you so much for joining us. Lunch for all of you all is arranged in the first floor lawn, so I would request you all to please move one after the other over there. Following this, we have a workshop. It is on limited capacity, so I request you after the lunch that it will be on first come, first serve basis only. Please carry all of your belongings that you have here along with you for the lunch, because we're going to transform this room that is more appropriate for the workshop. Now, as a token of gratitude, we have a small swag kit outside. I'd request you all to please collect it before you leave for the day. Thank you so much, everyone. It's on the third floor. The lawn is on the third floor. Thank you.
Okay, they should be back on.
Please be back at 1:30 for the workshop. Yeah. Please carry all of your belongings. If you have your bag or if you see your friend's bag here, please pick it up. Send you an email as well after the event is done, so you get credits to try out these labs. So even if
No, I want the live streaming link because
we'll send you. We'll send everybody. You want it right now? I'll give it to you right now. Just hold on.
so that
Can you go to? Sure. This one, this room only. We're going to change this. Can you go on Google?
And then you were telling first come first serve. I might as well go home and.
No, I agree 100%. Thank you. Go on LinkedIn. Yeah. Okay. So that you can share it with your friends as well if anyone else wants to share. You can just search for Google Cloud.
Google Cloud.
Yeah. There should be a page. Where are the Google Cloud pages?
Company.
Okay, it's a page. But please have lunch. And
Thank you so much.
But just to reiterate, we are going to build a patent search application with AlloyDB, embeddings, vector search, and Vertex AI, of course, right? So this is the architecture. The patent database, the data itself is stored in AlloyDB. The embeddings, the vector store is going to be AlloyDB's PG vector. Like I think we discussed this even in the morning session. It's a Postgres-compatible database. And it has all generative AI capabilities inherently. So you will be able to invoke Vertex AI APIs from within the scope of AlloyDB itself. So that's why you see the patent DB and the PG vector, ML integration, all within the scope of SQL itself in that small snippet over here if you're not able to read it. And embeddings, of course, embeddings also is in Vertex AI, the API, but we are going to invoke that from within SQL query itself. You will call it from AlloyDB itself. And the search text, of course, this is what you as a user or any end user is going to enter the search text, converted into the search text that the user enters is converted into embeddings, and the catalog, patent catalog is also converted into embeddings behind the scenes already. And these embeddings we'll compare against each other to do a similarity search, whether it's cosine similarity or whatever it is that you want to, algorithm you want to use. We'll use cosine similarity today. And then we'll do a real-time match and for what the user wants. How will we do that? We'll just deploy the small solution on the web serverlessly. All right, so this is what we are going to build. We are using these services, AlloyDB for PostgreSQL, we discussed that. Gemini models for embedding, text embedding, Gecko 003. Cloud Run functions, previously known as Cloud Functions. It's now called Cloud Run Functions. Right? It's a serverless platform for event-driven programming. You can quickly deploy your functions as serverless cloud functions on Google Cloud. Cloud Shell IDE and gCloud CLI. IDE because you have to write your code somewhere. So we'll be using Cloud Shell terminal for that. We'll also use gCloud commands for interacting with all of Google Cloud services and also for executing and anything that you want to do with the Google Cloud services and the code. We already saw a high-level flow diagram. Now this is kind of the architecture diagram, as you can see right here. For AlloyDB instance creation, you will have to do some default network setup, and also we'll see that now. And you will also have to enable serverless VPC connector in order to interact with that from your Cloud Run functions serverlessly. So that is why that's covered in the heart and center of this architecture diagram. Don't worry about it. We will do that hands-on, and it's also detailed in the code lab steps. So you will do it anyway. All right? And you have the application running in AlloyDB, and you have Cloud Run, which is invoking that application, interacting with the user request. Moving on. This we already discussed. Step 1 is the creating the instance, creating the cluster, creating the instance, creating the table, loading data. Step 2, you will install all the necessary extensions, right? Like PG vector extensions to store embeddings. You will store you will enable the, generative AI extension, and then you will provide access to service account user or the AlloyDB database user. So granting access, granting embedding function execute access. So you have to provide all the necessary access as step 2. Step 3, what we'll do is we'll insert data. That's what I said. Data is coming from BigQuery. It's already ready. You just have to run the insert queries. And then step 4, you will call embeddings function on the data that is there in the database using text embedding Gecko model from AlloyDB SQL itself. And finally, you will do vector search against the data in the database for the user query. Right? So in real time, you'll also convert the user query into embeddings, and you'll put the pieces together and run it in a Cloud Run functions. All right, so let's get started with the code lab. Please have your code lab open and handy. So we have covered the first overview. Now we are going to go to the second step. They've started the live stream? Okay, the code lab is starting right now, so if you want to start the live stream, this is a good time. Is that okay? Cool. So we are going to build a patent search application with AlloyDB, vector search, and Vertex AI, and we'll use the RAG architecture for implementing this, like we already discussed. Before we begin, this is the first step we are going to do. like setting up everything that we need. You already created the Google Cloud Console project, you activated credits, you linked the billing account to your project, and you have an active project up and running. So what is next? We'll use Cloud Shell, right, for commands, for interacting with services, and for writing code in the editor. So we have to activate that. So how do we do that? I'm going to have my Google Cloud Console open. All right, so if you see, right next to the search bar, you see Gemini, and right next to that, you see Activate Cloud Shell icon. Go ahead and click that. Once you click that, if it is the first time you're clicking it, it will take a few minutes, and it will ask you to enable APIs. Go ahead and click the Enable API button if it is prompting. It is self-explanatory. And it should open this Cloud Shell terminal. So as soon as you activate or you start Cloud Shell, as soon as you click that icon, it provisions you with two things. One is Cloud Shell terminal, and another one is Cloud Shell editor. So basically, it's a machine with storage and compute. Storage so you can write your code and save it. Compute so you can interact, run commands, and interact with all of Google Cloud services, your own code, and so on and so forth. So this is the terminal. To toggle between terminal and editor, I'm going to use this Open Editor button. So if I click that, it'll take a few minutes and few seconds, and it'll load the editor. And if I want to go back to the terminal, I'll again click this Open Terminal. Or you can have two tabs open, or you can have one open on top and one open the bottom, depending on how you're convenient. All right, so I have the command open right now, the terminal open right now. Going back to the code lab. So we are at step 3, that is done. Step 4, you don't have to do it right now because you would have just authenticated and got in. So hopefully you have. So how many of you are seeing the terminal like this with your project ID showing up here? Your project ID is showing up, right? If it is not showing, you have to run that command that is displayed right above that line. gcloud config set project, where it shows the square parenthesis project ID, replace that with your project ID. It's not required if you're already seeing your project ID here. If it's not shown, then you have to do a gcloud config set project ID, okay? So hopefully, looking at the show of hands, I think all of you have the project ID showing up. So we are all set there. Going to step 7, which is enabling all the necessary APIs. Now, we do it beforehand because we know all the APIs that we want to build. Typically, when you're actually starting to code or build or configure, you already have designed it. You've made up your mind as to what your design is. So this should be ready. But even if you don't know and some service evolves along the way, that is fine. You can always enable the API on the fly as it is required. But now, since we already have designed it, we know for the most part what services we need to enable. So copy this gcloud services enable command from the code lab, step number 7. Copy it as it is, and go to your Cloud Shell terminal, paste it, and enter. Take a look at all the services you're enabling. It will ask you to authorize. Go ahead and click that. It will open up your, it will ask you to choose the account. It will ask you to allow, do all the steps that are required. And then give it a few seconds. So in this step, using this command, we are enabling AlloyDB, Compute, Resource Manager, Service Networking, Cloud Run, Cloud Build, Cloud Run Functions, and AI Platform. AI Platform is your? What does AI Platform refer to? Vertex AI. Amazing. So it's taking longer than expected. I don't know why, so let's just give it a, there's an error. Probably I have unnecessary stuff. Wait, what have I done? Rate limit exceeded. Service usage, maybe that is not required. Compute. Oh, no, that is not the problem. Network connectivity issues. Why? All right, there is another way to activate it, just to, that's why there was an alternative provided. If you see, the alternative to the gcloud command is through console by searching for each product. So it will eliminate the ones that are not already there. So this is a safe bet. Go ahead and click, copy this link and go back to the browser where you are. The link is a hyperlinked word, if you notice. It's a blue-colored hyperlinked word. Right-click it, copy the link. Don't open it in the browser where it is open. Go to the browser where your Google Cloud Console is open and open that copied link over there. This should filter out the services that are not available for you, so don't worry about it. Go ahead and do this instead. All right? So it should list the APIs that are not already enabled in your account. Go ahead and click and next. And you should see the APIs. It's almost the same APIs that I had before, except for Vertex AI. I don't know why Vertex AI is not showing up. Probably because if you notice, the link has a billing success equal to true. After aiplatform.googleapis.com, you can remove everything and then hit enter. It should not be a problem, but sometimes it doesn't recognize the last one if it has a few things appended towards the end. Okay, so now see, I'm getting the Vertex AI API as well. So there was some percentage 27s or something appended, so that's probably why. But you should be able to see all these things, including Vertex AI, and then click enable. It'll take a few seconds, and it'll enable your APIs. Authentication, okay. Okay. So, turns out we have not clicked on authorize when it asked us to. I actually just skipped it on purpose. I mean, not on purpose, of course. I just overlooked it. I was looking for where it opened, I didn't see. So that's why that command failed for us in G-Cloud. Some of you may still not be able to do anything without authenticating it, so go through the other steps in the code lab. Some of the folks are facing that apparently. So remember, we skipped a few steps here. G-Cloud auth list, G-Cloud, this one mainly, G-Cloud auth list. So this will help you make sure this will ensure that you're authenticated to the Google Cloud account. If you're fine until now, and if you've already enabled the APIs, you're good. You don't have to go back and do this step. But if you're continuously facing errors, do this. But if you copy the link, the hyperlink method, it will automatically ask you for authentication then and there, so you don't have to go through the step anyway. Show of hands, how many of you completed enabling API steps? Okay, the others who's not raising your hands, any questions? Any issue? Folks with issues in the enabling API step? What is the issue? Vertex AI is not showing up. So that's what I'm saying. Go to step 2 of the code lab before you begin. Scroll down. Right below the 7th step, you should see a line that says the alternative to the G-Cloud command is through the console by searching for each product or using this link. The link word right there is hyperlinked. Right-click and copy that link address. Go back to your browser window where you have Google Cloud Console open and where your credits are activated. Open a new tab, paste it, remove the unnecessary thing in the end where it says percentage 27 and billing success equal to true. Starting from percentage 27 to the end, remove everything. Not that it is wrong, but for some reason that is ignoring the AI platform thing. So just remove that bit and hit enter. You should be able to see the APIs that you're enabling. Confirm project, click next, and then you should see the same list that I'm seeing right here. And then click enable, you should be able to enable it. Is it fine? Is it clear for folks who were not able to enable it? Done? Perfect. There was one more person over there who wasn't able to enable API. Done? Okay, very good. So I've also enabled it, so we are all set. So I'm going to just click on Google Cloud logo and come out of it. Now move on to third step of the code lab. We are going to prepare our AlloyDB database. So first things first, like we saw in the flow diagram, first step is creating a cluster, creating instance, creating table, right? All three things we'll do in one shot. Not one shot, but one by one in the first step. So how do we create a cluster and instance? Let's go ahead and do it in the Cloud Console way, okay? There are multiple ways you can do all these things programmatically. You can do all these things using G-Cloud commands. Or you can also go to console and do it. Or you can write Terraform scripts to do these things. But we are just going to look at it because you may have not seen these products in action. So we are going to go to the Cloud Console and do it manually. We will actually create the cluster and instance. So go to Google Cloud Console. If you're not on this landing page, click Google Cloud logo and go to the search bar. Search for AlloyDB. right? You should see that as the first item in the search result. AlloyDB, enterprise grade, PostgreSQL compatible databases. Click that. You should see this page. In your case, you may not see any cluster created already. That's fine. Just go ahead and click the Create Cluster button, icon type button that you see right next to clusters, right here. See it? Go ahead and click that one. Once you click that, you should be able to see these 4 options. Production workloads, production workloads with read pools, development and test workloads, development and test workloads with read pools. You can just go with development and test workloads. That's fine. Go ahead and click Continue. Configure your cluster. Just provide a name, any name. So I'm just going to do patent GEDD. Give a name that you like, right? It can be patent 1, depending on what you want your thing to be. Password, I'm going to give it as AlloyDB. You can also give the same, just for the sake of this demo. All right, all small. Database version, leave it as Postgres 15 compatible. Storage, leave it as it is. Location, I am going to change it to US Central 1. US-Central 1, I would recommend all of you to do that as well. US Central 1, okay? Networking, this is the important part. Please don't miss it. In my case, you will see it slightly differently because I have already tried multiple projects in AlloyDB, so my default is already set up. But you would see a different thing there. You have to click default and it will ask you to configure something. Yeah, go ahead and click the configure. So what you will see is there in the code lab or not. It's not there in the code lab. Let me see if the hyperlink has it. Otherwise, I'll show you, okay? So we are doing it through the console. Go to clusters, create cluster. Yeah, so what we have done here is we have selected the default and it will ask you to associate a IP range option. Select the default IP range, the automatically allocated IP range. Select that, select all the default options, and then automatically it will allocate an IP option, and it will take a few seconds to complete your network connection creation. Yeah? I'll give a few minutes here for your network creation, connection creation to complete. Please don't choose a custom IP range or don't try to change that. Just leave it with default values. And don't select the public access option. Just leave it with private access. Okay? I have chosen the pre-configured IP range, which is what you should also do. Nothing else changes. Just click continue once it's done. Once you click continue, you will see the basic info for configuring your primary instance. All right, so you have to provide a primary instance name. I'm going to give the same name that I gave for my cluster. You can also do that, or you can give a different instance name. Yes, what is the issue? For what? So your default is created then, in that case. So what is so your default right now is coming with a red exclamation? Okay. So the default IP range is taken up, is it? Why did that happen? Hold on, let me try it. How many of you were able to create your default network connection? Okay. How many of you are facing errors there? All of you have errors. Okay. No, but this AlloyDB's AlloyDB's network connection should be created, no?
Correct.
It's not the VPC yet. We are still.
No. So the private service connect, it uses the default VPC.
Correct, correct.
So if it's not created, it creates it. But then it somehow doesn't update and says, I can't.
It doesn't allow them to create the cluster if that is not selected.
Correct. So if they come back, actually the VPC
Is already there. Okay. Oh, okay. So do one thing. Just refresh the page. Apparently, that is what the issue. It is already created for some folks. Refresh worked. Please refresh and go back, and it should work. Don't retry because that's why it's giving you the error. Okay. How much time it took for you to create?
Around 2 minutes.
2 minutes. Okay. So just refresh and come back. It would take about 2 minutes, but it'll show up.
then it assigns the instances and connects to the network. So this will take about, you can say, anywhere between 5 to 10 minutes. 5 to 10.
Sorry? Instance, your thing is created, default? Okay, so instance ID can be the same as cluster, or you can give a brand new instance ID. Just remember the names. Or even if you don't remember, it's fine. You can always go back to the overview and find it. A single zone is fine. I'm just giving a few minutes for people to finish the cluster default network creation. But if you're already through, just hold on right there. Don't save anything. There are a few nitty-gritties that you need to configure. All right, how many of you got this created? Not the instance, just the network connectivity, the default one. Done? Okay, very good. Moving on, the configuring your primary instance part. I'm reusing the same name of my cluster to my instance as well. But you can choose anything you want as an instance name. Just adhere to the, I mean, it won't let you save it if it has any other special characters. All right, moving on. Machine type,
Tell it to take an
8 vCPU, 64 gig. Choose that. Don't choose public IP connectivity, just leave it at private IP. Network security, since it's a demo app, I'm just going to go with allow unencrypted connections. All right, just select that. Advanced configuration options, nothing changes. Go ahead and click create cluster. Now this will take a few minutes.
Exactly. So what it does is, AlloyDB, which is in Google's management, so on that instance, it creates a PSC attachment. And then later on we'll create it's got a IP, but then we are going to be deploying some code on cloud running cloud functions. So from a serverless VPC connector. So after networking, I click on create cluster. No, just last one. A public IP. No, you have put it. Just to make it a bit. Otherwise, it's a like, what is all this going on? Yeah.
How many of you got your cluster and instance created? Is it still going on? Okay. Error. What's the error? Performed? Tenant project creation. Just refresh it, give it a few seconds and refresh it. Why is that, I mean, instance failed? What is the other, the detailed error message? Anyone got their instance created? Done. Just refresh it, give it a few seconds and see if it is showing up in the list of instances. Click all clusters and try to find it.
These embeddings are like intermediate data. No. So now in Alloy DB, we'll be having a sample table, but we'll be adding an additional column for embeddings. So basically, let's say your product description. The instance is created. That product description will be converted into an embedding.
Yes, you have to create primary instance. No need to create read replica, just the primary instance is fine.
So it's something like this. When you give a, like, when we were doing a demo, she says, show me rugs for this. Correct? So now the question is, how do we map rugs to possibly hundreds of products in the table? So we are not doing a keyword match and a string compare. So what we've done is product descriptions existing in a table, you will see later. We create an embeddings column. Already. Now when you give a query, that embedding is generated and an embedding similarity search. In case we are running out of some, or they are observing something, what is happening from an outgoing. Why are so many people creating Alloy DB instances from Bangalore? By good amount, I mean between 5 to 10 minutes. So okay, so just try again create. Now it's already existing, so just go back. Just do a refresh and again create. You will see a default. And again try to create it. Continue. Now give the details again that whatever it was asking. No, don't just create anything. Go to the steps. We have given you the name of the cluster ID. Step number 3. See, you see there, cluster ID, name, password, because these are used later on. So use that and select the default one. Should create.
You got your instance created? Still create. Still creating. Done. Instance also. You already had or you created now? You going on. One or two?
For some, it's like at 5 minutes plus. Going on.
Okay. Mine is going on too.
then something looks very odd. Click again, setup connection.
While it's getting connected, just leave it alone and we'll try and set up the web application parallelly. Okay, so that is another thing we could do. Not that I want to cause chaos, but we're just waiting. It's going to take 5 more minutes at least. So let's go ahead and do the other parts. If you open the code lab, we are at step 3. We still have to do enable extensions, granting permission, creating the table and all that, and then loading the data set. But we are not going to do that right now because instance needs to be completed, like created. So what we're going to do is, we'll quickly jump to step 7. Just do a couple of things from enabling preparing the code up and running. We won't execute it, we won't run it, we'll just create and deploy this. Okay, so how to do this? So we are going to create a Cloud Run function. Multiple ways to do it. Since I already have the GitHub repository available, we can just clone it and keep it ready. Or if you want to go through the experience of creating a brand new Cloud Run function on your own, I'll show you how to do that as well. You can watch and decide if you want to do that, or just do a git clone repo on your Cloud Shell terminal. Okay, so I'm right here in my Google Cloud Console. Where am I? Here. So this is still happening for me. The instance is getting created. So what I'm going to do is right-click on my Google Cloud logo, open link in new tab. I'm just going to create a new tab with Google Cloud Console. I'm going to, in the search bar, look for Cloud Run Functions. First one, click that. We are just setting up Cloud Run Functions while we wait. All right, so I'm just showing you how to create Cloud Run Functions from console. There are 3 ways that you can do this right this moment. 1, through the console, like I'm showing. 2, through the editor, where you will bootstrap a full application, Cloud Run function application. Or 3, just cloning the GitHub repository that I've already created. I'll show you all 3. First one, once you click Cloud Run Functions, it will open this console and it will list all the functions that you have, if you have any. If you don't, it will still fine. You'll just see Create Function button. Click that. It will ask you for the function name. Environment, leave it at Cloud Run Function. Don't change it. It shouldn't be first gen, just keep it Cloud Run Function. Give it a function name. Yeah, relevant to the use case. Region, I'll leave it at US Central 1 because that is where our data set or our AlloyDB instance and cluster is getting created. So I'll leave it at that. It's convenient. Because it's a demo application, I'm going to allow unauthenticated invocations. So I'll click that option button. And expand runtime. Just for the sake of testing and other things, I'm going to set the timeout as 180 seconds. Okay. And under Connections tab, in Runtime Build Connections and Security Settings, go to Connections tab. Ingress settings set as allow all traffic. Leave it as it is. Go to Egress. You should see Network. And it says None. Select that drop down. You should see Add New VPC Connector. Go ahead and click that. It will ask you to enable the API if this is the first time you're doing it. So go ahead and enable the API. Then you will see a Create Connector dialog that you're seeing in my screen. You will see in yours as well. Typically, for a Cloud Run function, this step is not required. You don't have to always create a VPC connector. Why are we connecting this right now? No. Because we are connecting to AlloyDB, only because AlloyDB functions this way. You saw, remember the architecture diagram that we saw? You're creating a network there as well, right? Internally. So you have to, the only way you can connect to AlloyDB from Cloud Run Functions or any serverless environment is by using this external VPC connector, because we have a private connection setup. If you remember, we haven't chosen the public one. That's why. Otherwise, typically, you don't have to do this. You can just give service account permissions as and when it's required, right? So here, we are doing this for that purpose. Provide a connection name. This can be anything. I'm just going to give it as something. Region, keep it at US Central 1 as well. Network. Is default showing up for you? Go ahead and select that. subnet drop-down, choose custom IP range, and in that IP range thing that pops up, just type in the one that is showing in the bottom, in the text, 10800.
Cloud run function.
10.8.0.0. That's it. The /28 is already there. Just grayed out. Expand scaling settings. This is important. Keep minimum settings instances as 2, maximum instances, keep it at 3. Otherwise, it will not have the enough quota to create it. So 2 and 3. Instance type, F1 micro, because E2 micro is a little more scaled instance, and we don't need that. Choose F1 micro. Maximum instance is 3, minimum instance is 2, and click create. These steps are also there in the code lab. We are just jumping the gun and doing step 7 already. Reason being, we are waiting for the instance to get connected. Instead of just chit-chatting, I wanted to engage you so that we can have Q&A time later.
Make sure it's the max instances at 3 and F1 micro because...
Yeah, don't forget to change the maximum instance settings. Otherwise, it will not create. It will fail. 3. Because this is... Okay, my instance is ready. How many of you got your instance ready in the other tab? Okay, all of you. Okay, that's great. All right, since the instance is ready, we can jump back while you leave this VPC connector to get created on its own. I already have multiple of these created, so I have an error. But how many of you got it created, the VPC? Error or going on? Going on. Okay. I'll just have to... Yeah, that happens typically when I think I've used it more than once, the same subnet range. Either I have to go and delete it from the VPC connectors or use the default one that's already there for me. Sorry? Route all traffic through the VPC connector. So if you already complete, how many of you completed the VPC creation? And right below that, you're seeing 2 options, right? Route only request to private IPs and route all traffic. Choose route all traffic, and then click next. Then you see the runtime, right? You have to choose Java 11. 17 is fine too, but just go with Java 11 for now. And you should see the source folder and pom.xml. You can just deploy it right now or go to the code lab. Those who have already done with the VPC setup. Go to the code lab. If you scroll in step 7, you will see the GitHub repository link. There is pom.xml. In step 7 of the code lab, point 3, you will see pom.xml hyperlink. Open link in new tab and copy the contents of your pom.xml from the GitHub repository over there. Copy that. Come back to your Cloud Run functions console. Replace the pom.xml with the value that you just copied. And then expand the GCF2 FV2. Go to hello HTTP function.java. Here you have to be a little bit careful because the folder structure in the console and the folder structure in the Cloud Shell editor are slightly different. So I'll just show you that in a bit. If you notice, the package name here is different from the package name here, so don't replace the Java file as it is. Just copy the imports, put it over here. Don't have duplicates. Other things are fine. LOHTTP function, all this is fine. Just that the content inside can be completely copied and pasted here within this function. All right? And there is a function in the bottom, just copy that entirely. Just the function, and paste it right above the last close parenthesis. So here you need to change a few things, but we don't have our instance ID, project ID, cluster ID yet. So don't do anything, just leave the tab as it is, go back to the other tab where your instance is successfully created, right? So expand the connectivity label over there. You see a drop down, expand it. You should see the connection URI. Do you see it? Do you see the connection URI there? Yeah? So just copy the connection URI, just click the copy icon, copy to clipboard icon, come back to the code, paste it where it has your instance name, right? You can just paste it completely in the placeholder. That's pretty much it, right? Just paste it. Everything else is the same, nothing else changes. I'm hoping you have AlloyDB as the password as well. If you have a different password, please replace that. Because I instructed you to set it as AlloyDB, I'm not changing it. All right, so we have all the changes we need. Everything, entry point, everything is good. So go ahead and click deploy and leave it alone. It'll take a few seconds, maybe like 30 seconds or so for this to complete deployment. So we'll leave it at that. Go back to the code lab. Now we have to resume the database step, which we stopped with creation of instance. So I'm going to go back to step number 3. We have only completed creating the DB objects. Now we need to create a table, all right? How many of you have completed creating cluster and instance? Just those two. Perfect, ready to create the table now? Open the code lab, go to step 3, prepare your AlloyDB database, and copy the step that says create a table, copy that the DDL statement, create table patents data. Copy that, go back to your Google Cloud Console, open your AlloyDB tab, wherever you have AlloyDB open. On the left in the navigation pane, look for AlloyDB Studio. Go ahead and click that. It will ask you to sign into AlloyDB. Right? Click the database drop-down. It will show Postgres. Click the user, select that. Password, enter AlloyDB or whatever password you gave there. And go ahead and click Authenticate. It will take you inside AlloyDB Studio, the SQL editor. Go ahead and click Editor. Paste the DDL that you just copied. Go ahead and click Run. My statement is successfully executed. I have the table created right now. There is no data, just the table. How many of you got the table created? Show of hands. Okay, I'll give a minute for folks to catch up. Please create the table. How many of you got the table created successfully? All right, ready to do the next steps? Like I said, we need to enable extensions, PG vector extension, so you can perform embeddings, so that you can store vector data, right? Vector store. And then we'll also enable Google ML integration. Even though I don't think we will use Google ML integration today in AlloyDB. But remember, like I said, you can call any generative AI operation, Vertex AI eligible API, whichever is available from AlloyDB, directly from SQL query itself. So that is why you need to also enable that extension. So go ahead and copy both the statements from there. Create extension vector, create extension Google ML integration. Come back to your AlloyDB Studio editor, paste it, and run these two, create extensions. Done. Statement is run. It just takes a second. Create it. Perfect. Moving on. Granting permission. This is required because we want Postgres user to be able to invoke embeddings method, right? The embeddings function. So copy that grant execute DDL. Come back here. Paste it and run it. Done. Done. How many of you got through these steps? All right. So now this is the important thing. You have to grant Vertex AI user role to AlloyDB service account. Why? Because we are going to invoke Vertex AI APIs from AlloyDB. So service account of AlloyDB should have the Vertex AI user roles and permissions. That's why. It's very simple. Just copy this command. Multiple ways to provision access. You can do it through the console. You can do it through a gcloud command. I'm going to use this gcloud command. Just copy this. Go back to your Cloud Shell terminal, not the AlloyDB, not the cloud functions. But wherever you can, just click the Activate Cloud Shell, or in your case, it should already be open in some tab, right? The Cloud Shell, the black terminal. Go ahead, open that. It'll take a few seconds for me to load because I opened another profile so that I can show it from my Gmail account. So I'm just going to give it a minute. But you have your terminal open, so go ahead and paste it in the Cloud Shell terminal, the black screen, and then run that command. So there it is. I've got it. I'm going to paste it right here, these two, and hit enter. You don't have to change anything because most of it, all the variables are obtained at runtime. Go ahead and click authorize. Done. Okay? So role permissions granted. Yes, that's it. Just paste the project ID equal to command and the gcloud projects add IAM policy command. Just copy that and run it from the Cloud Shell terminal. How many of you got through these steps? Very good. We are at the last point of step number 3, which is we already created the table, but we forgot to add a column. Not that we forgot, we wanted to consciously, I wanted you to consciously be aware that we are creating an embeddings column within the same structured table that we already have, which means you're going to be able to store embeddings of any data. It can be an image, it can be a video, but you can still convert it into embeddings and store it in AlloyDB in your regular table. That's why I kept it as an alter statement separately. So go ahead and copy this alter table command, DDL. Go back to your AlloyDB Studio, editor. Go ahead and run it from one of the tabs. So I'm adding a column called abstract underscore embeddings, which means the column is named for its purpose. I'm taking the abstract of patents. We haven't seen what the data looks like yet. That's why. I'll show you the data so you'll understand, but for now, just let's do the DDL statements. So I'm adding a column called abstract embeddings, and this is the vector dimension, 768. Okay, typically this is the basic one, unless you want to go and change it. In this case, for the most use cases, you can use it as it is. Now, step 3 done. Step 4, inserting data. How many of you completed all points in step 3? Nice. So all we have done so far is set up database, cluster, instance, table creation, extension, PG vector and all those things, granting permissions, the roles and everything, and then parallelly we just kicked off cloud functions, but that's okay even if you didn't get to it. But other things, created VPC, serverless, sorry, what is that? The private connection for AlloyDB, the default network connection, and then you created table, you granted all the necessary permissions. Now, in step 4, there's only one thing we are going to do. We are going to insert data to the table we just created, and we want to just look at what the data looks like. So where is the data? Like I said, I already prepared the SQL, insert SQL file for you. Just right-click on that hyperlinked file in that step. Step number 4 of the code lab. Insert into patentsdata.sql. Right-click, open link in new tab. You will see that this file has several insert scripts. You don't need so many, just copy the first 5 or 10. I'm just going to copy 10, okay? Remember, this is a trial billing account, so the trust on trial billing accounts are typically very low on purpose. So which means that some generative AI commands may not function at the same quota and limit and scale that it's supposed to, usually, because it's trial billing account. So keep the data set limited so you can try it out. So I'm going to just copy 10 insert SQL queries from here, and I'm going to go to my AlloyDB Studio, paste it right here, and I'm going to run this, and it's all inserted. Done. Step 4 is done. Now I'm just going to look at what the data looks like. I'm just running a select star from patents data because it's only 10 records. It's okay, I can do a select star from here. And there's not too many columns, it's limited anyway. So as you can see, I have patent ID, type of patent, which is utility or whatever it is, design, and then number, the patent number, country where the patent was issued or submitted, date of patent, abstract of the patent. If you expand this, you will see this has a full abstract of what this patent is all about, which is a big deal because to get hold of information like this, historic information like this, data is just not lying around like this. BigQuery has a lot of these data sets, and that's why it's easy for us to leverage those in building such applications. Title of the patent, the kind of patent, number of claims on the patent, file name, related file name, withdrawn, has the patent been withdrawn, Boolean, abstract embeddings. If you notice, this is the field that we added, abstract underscore embeddings. The reason why we added this is because we want to store the embeddings value of the abstract data. So what is embeddings? We already saw that in the demo this morning. Embeddings look just like numerical, like array of floats, right? It is nothing but just array of floats. It is a numeric representation of any form of data, be it text, image, video, which is a groundbreaking thing. Not that it's new, it has existed from not time immemorial, but it has existed for a long time because that's how searches used to happen, YouTube searches, relevant matches. Embeddings have been around, it's just that they were not available for all of us to use it just like we're consuming it right now. It was not at the tip of your endpoint, right? But these were already there, but nevertheless, it's getting popular now, so let's learn what it is. So whether your data is an image or a video, if I'm saying I want to see a blue yacht with yellow painting and labels on it, right? Now this is a text description. If I convert this into embeddings, and if I actually take a picture of a blue yacht with a yellow label text on it, and convert that into embeddings, and compare these two, they are comparable. So you're not comparing an image to text, you're comparing embeddings to embeddings. So just picture the amount of performance improvement and save and resource utilization you get by just doing this kind of search comparison instead of doing so many integrations to compare these two to a compatible format first and then comparing. Right? So in short, that's all embeddings, comparisons, vector search is all about. Right? Moving on. So now our abstract underscore embeddings is going to store the embeddings value of the field abstract. All right? So how am I going to do that? That we are going to see in step 5. Go back to your code lab. Go to step 5, create embeddings for patents data. If you can see, there is a simple select query that tells you how to invoke the text embedding gecko API from SQL, Postgres, within AlloyDB. And here is a statement that I'm just passing, which I want converted as an embedding. So I'll copy this. This is just a sample. This is not an update statement. I'm just going to see what embeddings looks like. And I'm just going to run this. So embedding is the function. This is the embedding API. And this is the text I want to see converted to embedding. So there we go. We are seeing the embedding result right here. Now, this is not our use case. Our use case is to convert abstract stored in the table into embeddings. So what I'm going to do, scroll down, copy the update abstract embeddings vector field DML from step 5 of the code lab, the last segment. Just copy this update DML from here. Come back to AlloyDB's Studio, AlloyDB Studio SQL editor, paste it, and you should be good. Because this is trial account, you might get quota exceeded even for 10 records. It's possible. Not always. Sometimes it's possible. In which case, update it 2 or 3 records at a time, but you should be able to do it. Just use a where clause to choose the ID that is there in your table and update it. You know how to do it. Just add a where clause. I'm just winging it. I'm also using a trial, the same billing account that you're using, to see if it's working for me. Because it's trial billing account. Usually, AlloyDB updates and inserts are pretty quick. Like, it just happens in a snap. But it takes time because of this billing account, and mine is done. How many of you got your statements updated? Sorry, records updated. Okay? Very good. Just go ahead and run the select SQL again and see if all your records have your embeddings data generated. And I see all the embeddings generated for all of these 10 records. Now take a look at the abstract so you know what you want to search for, because you don't want to search for something that's not there in your 10 record database. So just take a look at the 10 records that you have copied and get an idea for what you want to actually test, right? So I'll get an idea on my own, but it's not necessary that we both copied the same 10 records, right? I don't know if you copied the first 10, but in any case, just see what you want to search for. Something that can be close enough to what is already there. Embedding is a function here. So that's why we enabled the extension for PG vector, the vector. So that, and then you gave embedding function permission to the user. So that talks to Vertex AI to get the embedding API behind the scenes. Inherently, AlloyDB is capable of doing that. Yes, the update, right? Yeah, that's what I said. It's possible that it happens. So include a where clause and do 2 or 3 records at a time. For some of you, it might happen. Did you run the permission step in step number 4 of the code lab? See, some of you may get quota exceeded or some error while you're running the update statement. This is because of the trust on the trial billing account, which is fine. Just include a where clause in the update statement and choose 2 or 3 records at a time to update, or maybe 1 at a time. So let's say I'm just inserting where ID equal to this. So I'm just updating 1 record, in which case it will be faster. Okay, it's not an integer, so just use a string. Literal. All right, so update 1 or 2 records at a time. Because like I said before, it's trial billing account. So you will not, some of you might get errors. It just coincidence that some of you get all 10 records updated. Some of you may get 1 at a time updated. So I'll give a few seconds here. Once you complete this, we are almost done. We are going to write a query to actually perform the vector search and compare the user search text against the 10 records that you have in the database. And then we'll take the application to web. We already prepared the cloud functions. Remember, my cloud function already deployed. It took about a couple of minutes. It's successfully deployed. As you can see, where is it? Right here. Not this, here. See, you see the green tick mark? My cloud function is deployed. But I'm not going to test yet because We are still doing the database step. We'll finish there and then come and execute this. Okay? How many of you got your update statements done? Okay, good. I'm just going to wait till 2:53, 1 more minute for folks who are catching up. Just finish that. And then quickly we'll run step number 6 of the code lab, which is performing vector search. If you notice, we have not gone in and out of database and programming platform. We just did it parallelly, the cloud functions, but we have not actually invoked anything from the database in cloud function. That was just a parallel track we were doing because we had time while we were waiting to create the instance. But if you notice, all the steps that we executed now are from AlloyDB side only, which means not only did you create database, create tables, stored the records, you also created embeddings, converted data set also into embeddings, stored that into embeddings, updated it. Now you will also do vector search, everything from database. All you have to do now is just copy the query and wrap it with a Java function or a Python function or whatever and deploy it. That's it. And you'll get a REST endpoint, which you can then use in any of your applications or chatbots or whatnot. That's what we're going to do right now. Let's just give a minute for folks to catch up, and then we'll run vector search. So vector search itself is actually another vector database. But we are not using that vector search right now. We are using vector search, the concept, which is similarity search from AlloyDB, right? So typically, even before all of these generative AI became a thing and other things, we still had cosine similarity, we had Euclidean distance, all these algorithms to measure relevance, contextual matches, and all that. We didn't call them as embeddings back then, or we didn't call them as vector search back then, but they all existed. How many of you have used cosine similarity in the past? Even before, yeah, right? So these are basic concepts you would know. Cosine similarity is how close the search text is with any of the things that is already there in your database. Euclidean distance is how far away it is. What is the distance, right? So based on that. So today we'll use cosine similarity. Go to step 6, copy that select statement, come back to your AlloyDB editor, Studio editor, paste it in there, click format, so you can understand the query better. As you can see right here, what I'm doing is I'm choosing a combination of, a concatenation of ID, hyphenated ID and title. I'm calling that field as literature. This is just a place, this is just a boilerplate thing. I'm using this field to identify the patent, that's all. And then what I'm doing here, this is all, this is, one line is all it takes to do the vector search, the cosine similarity. Order by abstract embeddings. Remember the field we created to store embeddings, which is the database part? So abstract embeddings, the double-edged arrow, the edge pointing on either side, the angle brackets, this represents cosine similarity. Euclidean distance has a similar type of equals. It just will not have both double-edged arrow. It's a different sign, but it's just that one operator that determines what distance method you're using, right? So this means you're using cosine similarity. And the embedding function we already saw, you're calling embedding. We already decided we are going to use text embedding gecko 003 API. And this is the search. This is my new idea. I have a new idea for building a new natural language processing based machine learning model. That is my patent idea. So I want to see how many patents in the past already exist in and around this topic, right? So I'm passing my real-time English language search text here and colon, vector, right? So this is what implies that you're doing a vector search here. Limit 10. I'm just limiting my search results to 10. You only have 2 records, just limit your search result to 2 or 1, okay? I'm going to run this. So now you will see if there is any related data. I don't know if it has anything related to this. If it doesn't, that's fine. We might just get the closest possible response, right? It doesn't have to necessarily be the same. Now, this is the part you have to understand. In the morning demo, if you remember, how many of you were there in the demo? All of you, right? Most of you would have been there. If you noticed, I did the vector search, and then I said I'm tying it all together by making a call out to Gemini 1.5 Flash to validate if the responses are in fact good enough to send back to the customer, or you're just assuming that they are the closest possible matches, right? Because embeddings do not have the ability like, I mean, at least as of now, they do not judge like Gemini 1.5 Flash or any other large language model will do, because they are language models. Their nature is to identify whether your response or whether two things match. Whereas embedding, if you have a text, it will find the related ones. Even if there is no matching result, it will try to bring something that's the closest possible one, right? But that's not what your customer will want. Your customer will want to see what, or your user search, or even you will want to see what is only valid. Otherwise, just don't return anything. So that kind of arrangement you can only have with LLMs. So you would use an LLM on top of it to make a final call, right? But we are not going to do that now. We are just going to return embeddings. Okay, sorry, we are just going to return the matching ones. But even that you can do within the scope of query. Even if you want to include a Gemini call on top of this, what will I do? I'll just write a nested query on top, and on top I'll invoke generate_text. That is the method to invoke Gemini 1.5 Flash, and I'll pass the result and I'll call it, or Gemini 1.5 Pro or whatever, right? So it is straightforward. Everything you can do within the scope of query itself. So now, as you can see, it has got two responses which are not related. However, let me see if I can get anything that's related. Let's say a new equipment for fitness. So that is my idea, right? Now let's see if there is anything that's matching. Yeah. Do you see that? The first match, the closest one is exercise treadmill, which is very close to what I'm searching. The second one is adjustable seat and support system. I mean, not so much, but that's possibly what the closest match is out there. Or maybe it is something related to this in the abstract. This is just a title and ID. So you see what I'm saying right now? So everything is ready, and we have the response. That's it. This is vector search. This is how you return the closest matches. Now the last and final step, taking this to this application to web, which I've already set up right here. I have the Cloud Functions code. All I have to do is make sure the permissions, make sure it is available for anybody to test. I already made it unauthorized, meaning anyone can access the endpoint. I'm just going to check if it is still that way. Just going to add all users. Even though I don't need to add this because I'm just going to test it from here. It's not like I'm going to consume this in any other application, right? So let's go to, how many of you got your Cloud Function deployed? Oh, done? Anybody else got your Cloud Function deployed from the steps I showed? All right, so just take a look and try it out. It's one step right here in the code lab, step number 7. It's straightforward. I'm going to show you the testing here. So if you walk through the code in the Cloud Function, if you go to source, just walk through the code, you will understand that it is looking for a JSON attribute named search, right? And the search will have the user text, just like you saw in this query, right? So I'm going to say a new equipment for fitness here in my testing. The attributes label is search, and the value is the value that I passed in the query, a new equipment for fitness. Close the quote, and that's it. Now scroll down, there should be the testing has this option to run in Cloud Shell. So I'm just going to run this endpoint as a curl command, right? Because I want to see the response. Here we go. So it has set up everything for me. I just hit enter. So once the function is deployed, you will get an endpoint, yeah? You would have got the endpoint, right? You deployed it, you would have gotten HTTPS endpoint. And now I have to hit the endpoint with my JSON body request and then get the response. So my request is search followed by the search text. The text is a new fitness equipment. That is what I'm searching for. And here I have got the closest match, which is medical image display apparatus information, whatnot. Something that is closest to that. Medical equipment. It is also something related to equipment and fitness, which is fine. That tells us that it is actually making the comparison for real. All right? So this is exactly how we have taken vector search, all like embeddings, creating the table, creating embeddings, performing vector search, taking the all of this is in AlloyDB, And then just one step where you're taking cloud functions, cloud run functions to execute that from serverless service on Google Cloud. That's also, that's how you've taken your data from AlloyDB to the web without leaving the scope of database much. So you've implemented RAG. Which part of this is RAG? Can someone tell me? Which part of this is RAG? The vector search part, where you're converting it into embeddings and comparing. Converting the data set into embeddings is the retrieve part, and comparing, actually we are not calling the final Gemini, which would make it a perfect RAG. Here we are just returning the closest matches, and we stop there. As a homework, why don't you try to complete this query by writing a nested query on top, another query on top, and invoke Gemini large language model 1.5 Pro or something from AlloyDB, and validate if the two matches that you get are in fact relevant to what the user is asking. So how can you check relevance? For example, if I want shoes that are made of leather, not made of leather, and if embeddings return something with leather, then Gemini should be able to decide, oh, the user wants no leather, but your response has matched leather. So don't send this to the user, right? So Gemini will make that final call. So try to implement that. Yes, so which part is RAG here? The part where we converted the data set into embeddings and used that as a reference for our real-time data that is coming in, the comparison that we are doing as a context, that is the part which is retrieval augmented generation. Of course, here we are just returning the vectors that are matched, and we are not actually performing generation on top of it, but that is something for you to work on it as a homework. There are a couple of blogs at least that I have written. Roman has co-authored one of the things recently in the e-commerce blog. So do check out our Medium blogs. You will find the Gemini call as well, the large language model call from SQL also, on top of the vector search result. All right? Thank you, everybody. I hope you are all able to complete the workshop. If not, the lab is available. You have the credits. Feel free to complete it. And remember one last thing, just delete the project or delete the AlloyDB instance once you complete once you try out the experiment, because the instance will take up some resources. Anyway, you're using trial billing account, but still, if you want to keep using that $1 or $2 that's remaining, you probably might want to delete the cluster and instance that you create. Thank you. Have a great day. Oh. Please don't go away.